The red, parched earth under your feet is shaking. Large cracks are opening in the ground, threatening to swallow you. But unlike on Earth, these quakes aren't coming from within the planet. A threat coming from space is triggering them. Scientists have made a shocking discovery about Mars quakes. By using AI and NASA's InSight data, they found out that some of those tremors are caused by meteorite impacts. It means that Mars gets hit 2.5 times more often than we thought, and new craters are forming all the time. But the scariest part is that these impacts don't just shake the ground. They send powerful shock waves deep into the planet, revealing a hidden seismic highway and an unstable interior, unlike anything we imagined. This changes everything we thought we knew about Mars. So now, the big question is, what else is lurking beneath the surface? But let's follow scientists' train of thought first. They took Marsquake data from NASA's InSight lander and compared it with fresh impact craters spotted by the Mars Reconnaissance Orbiter. That's when they discovered that some impacts create a seismic highway through the mantle instead of being absorbed by the crust. Even though NASA shut down InSight in 2022, its data is still precious. The lander, which placed a seismometer on Mars, recorded over 1,300 Marsquakes, some caused by underground rock cracking under heat and pressure, others, apparently, by meteoroids slamming into the surface of the red planet. By studying how seismic waves move through the crust, mantle, and core, scientists keep piecing together Mars's deep structure. In the past, researchers already linked impact craters with seismic data. But these new studies are the first time when a fresh impact has been connected to quakes detected in Cerberus fossae. That's a highly active region 1,000 miles away from InSight. Scientists have discovered this 71-foot-wide crater much farther from NASA's InSight lander than expected, if we consider the strength of the seismic waves it produced. Mars's crust was thought to absorb most of the energy from impacts, which would limit how far seismic waves could travel. But the analysis of this crater revealed that, instead of getting dampened, the waves took a more direct and deeper path through the planet's mantle. This unexpected finding suggests that Mars has a seismic highway, which allows quakes to spread much farther than previously believed. Now, the InSight team will need to reassess their models of Mars' internal composition and structure. And then, we might better understand how impact-generated seismic signals can reach such depths. Manually sorting through the vast amount of data would have taken years. But luckily, these days, there are new tools, and scientists can go from tens of thousands of images to just a few in a matter of days. So, researchers focused on finding craters within approximately 1,800 miles of InSight's location. Their aim was to identify those that formed while the lander's seismometer was active. By comparing before and after images from the context camera over time, they identified 123 fresh craters to cross-reference with InSight seismic data. Out of those, 49 craters were potential matches for quakes detected by InSight seismometer. And after conducting some more analysis, the team decided that the 71-foot Cerberus fossae impact crater was the main finding. This discovery is likely to help scientists differentiate between signals from internal quakes and those caused by meteoroid impacts. Initially, they believed that Cerberus fossae produced a lot of high-frequency seismic signals linked to quakes originating inside Mars. But the new data suggests that some of this activity may have been caused by impacts, not internal processes. Another mystery scientists haven't been able to crack for 50 years is why Mars is split into two very different halves. But thanks to recordings of Marsquakes, they may have finally found the answer. Since the 1970s, researchers have known that Mars has two distinct regions. The northern lowlands cover about 2/3 of the planet's northern hemisphere, and the southern highlands make up the rest. The southern highlands sit about 3 miles higher than the northern lowlands, and the crust, the planet's outer layer, like a shell, is thicker in the south. This strange divide is known as the Martian dichotomy. There are two potential explanations for this imbalance. One theory suggests that an unknown internal process within Mars created the difference. The other claims that a massive collision, probably with a moon-sized space rock, or several smaller impacts once reshaped the planet's surface. But Mars' surface is extremely old. That's why pinpointing exactly what happened has been difficult. But now, a new study, published on December 27, 2024, has used Mars-quake data from NASA's InSight lander to figure out whether the cause of this difference lies deep inside the planet. InSight was positioned near the boundary between the northern lowlands and southern highlands. Its mission included recording seismic data from Marsquakes, which travel through the planet's mantle, the rock layer beneath the crust. So scientists compared how these waves moved under both lowlands and highlands. They looked for differences in the planet's deep interior. It turns out that the seismic waves lost energy much faster when traveling through the southern highlands. It means that the mantle beneath this region is significantly hotter than in the north. It's compelling evidence that internal planetary forces, rather than an external impact, caused Mars' unusual split. The research team believes that the temperature difference between Mars' two halves can be traced back to ancient tectonic activity. It once shaped the planet, but later stopped. At some point in the past, Mars had moving tectonic plates, like Earth's. As these plates shifted, they, along with the molten rock beneath them, could have created the Martian dichotomy. But eventually, the movement stopped, leaving behind what scientists call a stagnant lid. That's a thick, immobile layer over the planet's molten interior. If this turns out to be true, it might mean that the mantle beneath the southern highlands is still pushing upward, while the mantle under the northern lowlands is sinking deeper toward the planet's core. This ongoing process could explain why Mars' crust is thicker in the south. At the same time, we can't completely rule out the idea that an external impact created the dichotomy. Some recent studies suggest that a giant collision could still be a possible explanation. To solve this mystery for good, scientists will need more Marsquake data and detailed models of how Mars originally formed. By the way, if you ever decide to visit Mars, you might come across the hero of our video today, the InSight lander itself. It was supposed to launch in March 2016, but a problem with one of its instruments caused a delay. It was a vacuum leak in the seismometer. NASA rescheduled the launch for May 2018, and the issue was fixed in the meantime. But this delay increased the total cost from $675 million to $830 million. Still, InSight successfully landed on Mars on November 26, 2018. But over time, dust built up on its solar panels, making it harder to recharge. The InSight lander runs on solar panels and batteries, but it needs occasional wind gusts, called cleaning events, to clear dust from the panels. Unfortunately, the place where InSight landed didn't get enough of these winds to keep the lander fully powered. By February 2021, during the Martian winter, thick dust had covered the panels, and they were only producing 27% of their full capacity. To save power, NASA started putting InSight into hibernation mode, shutting down instruments gradually to keep its electronics warm. They hoped better weather would allow the lander to recharge and wake up by July 2021. In May 2021, the team found a clever way to restore some power by using the lander's arm to move sand onto the panels, helping the wind clean off some of the dust. But eventually, InSight was only generating 1/10 of the power from the sunlight than it did right upon arrival. In July 2022, NASA put it in low power mode to keep detecting Marsquakes. The lander kept operating until December 2022. On December 20th, NASA announced that InSight had lost contact with Earth on December 15th, and the mission officially ended on December 21st, 2022. It's staring at you, and you're staring at it. A giant eye that seems to be pulling you into an abyss. You're hovering over it in your space copter. But however scared you might be, you still need to do your job. So you send your copter down to the surface of the red planet. Right, that's where you are, on Mars. But first things first, you take a moment to remember everything you know about the fourth planet from the Sun. It's the last of the inner planets. Those are the planets that lie within the asteroid belt. They're also called terrestrial, since they're made up of rocks and metals. The atmosphere of Mars is much thinner than Earth's. It contains 95% carbon dioxide and a mere 1% of oxygen. In other words, Don't even think about pulling off your helmet. Anyway, there's no time to waste. You land on the surface of the planet and find yourself in a brownish-red world. That's a good thing you're wearing a spacesuit. This place is freezing cold. The thermometer sewn into the sleeve of your suit shows minus 80 degrees Fahrenheit. Time to take your first step on the Martian surface. The planet looks quite colorful, and the hue of a particular area depends on the minerals that make up the soil. The ground under your feet is covered in fine dust. It looks like rust. The same orange dust is in the air. Good thing you have your own supply of oxygen and don't need to breathe Martian air. The layer of this dust covering the surface of Mars can be from 6 to 40 feet thick. You hope you'll avoid getting swallowed by some Martian quicksand. You start walking, feeling very light. Mars is just 15% of our planet's volume and a mere 11% of Earth's mass. It means that gravity here is much weaker. Its pull is 38% as strong as the pull of gravity on the surface of Earth. You jump up and down and then try to run several hundred feet. Ha! You haven't even broken a sweat. What makes it harder for you to explore the place on foot is that the planet's surface is rocky, covered with craters and volcanoes, old dry lake beds, and canyons. You see something huge towering on the horizon, but you try to suppress your curiosity. You'll have enough time to figure out what it is later. Suddenly, a massive cloud appears in the distance. It looks as if a huge herd of horses is approaching you. In reality, you better get back into your copter and fly away as fast as you can. That's one of Mars's infamous dust storms. They mostly occur during the summer in the southern hemisphere of the red planet. They can sometimes cover the entire planet, and you see the largest ones from Earth. You hop into your copter and set a course for the eye that scared you so much. Winding channels that look like veins run through the eyeball. But the closer you get, the less it looks like an actual eye. Soon you realize it's a crater. It's giant, almost 19 miles across. Around the crater, which looks as if it has a pupil, there are other even bigger craters. They likely formed billions of years ago. That's when Mars had to withstand multiple attacks of space rocks. But why is the eye crater darker than the surrounding landscape? Scientists think that once there was Martian water in the enormous pit. Remember those channels? They were likely carrying that water. And since the crater was filled with water, it stopped some substances and minerals from eroding away. Now, remember that towering something on the horizon? It's time to go and explore it. When you come close, you realize it's the largest shield volcano in the entire solar system, Olympus Mons. It's more than 370 miles in diameter, which is almost the same size as the state of Arizona. You tilt your head. Wow! The mountain is 16 miles high. It's also rimmed by 4-mile-high cliffs. To picture the sheer size of the volcano, let's make some comparisons. The largest volcano on Earth is Mauna Loa, towering around 2.5 miles above sea level and stretching 75 miles across. Sounds impressive. But the volume of Olympus Mons is around 100 times larger than that of Mauna Loa. The Martian giant could swallow the whole chain of Hawaiian Islands from Kauai to Hawaii. But why is this volcano so large? It might be the result of lower surface gravity and higher eruption rates. Or the reason might be the red planet's crust, which is very different from Earth's. It's static. You see, on our planet, the crust is made of 15 to 20 moving tectonic plates. As plates move over hot spots producing lava, new volcanoes form, and the already existing ones become extinct. That's why lava can get to the surface through many vents. But on Mars, the crust isn't broken into the same tectonic plates as on Earth, and the lava has nothing to do but pile in one very, very large volcano. So, how about getting closer to the enormous mountain? But once you step out of your copter on Martian soil, the ground under your feet starts shaking. Well, that's a Marsquake. But how can it happen if Mars doesn't have any actively shifting tectonic plates? Specialists from NASA are sure Marsquakes occur when energy inside the planet gets suddenly released. It leads to rock fractures and cracks in the planet's crust. Another powerful jolt, and one of such cracks opens right next to you. You fall to the ground, afraid to move, but soon everything calms down. You wait for a couple of minutes, just to be sure, and get up. Oh look! Here's a perfect opportunity to explore the insides of the red planet. The crack is large enough to send a special research robot. The planet's crust is thin and consists of volcanic basalt rock. The mantle that surrounds the core of the planet is made up of thick silicates, oxygen, and some minerals. You can probably compare it with soft, rocky toothpaste. Mars's mantle is also much thinner than Earth's. It's just 800 to 1100 miles thick. As for the planet's core, it's made mostly of iron, nickel, and sulfur and is between 900 and 1200 miles wide. This core doesn't move. That's why Mars doesn't have a planet-wide magnetic field. Unfortunately, your drone is now lost in the depths of the red planet. You leave it there and continue your exploration. Your next destination is Valles Marineris. It sounds more like an Italian red sauce, but it's actually an enormous canyon, or rather a canyon system, that runs along Mars's equator. It's as awe-inspiring as Olympus Mons, more than 2,600 miles long and over 4 miles deep. The thing is so huge, it could span the entire continental United States from the Pacific to the Atlantic Ocean. Now let's make another comparison. One of the most famous canyons on Earth is the Grand Canyon in Arizona, but it's 10 times shorter and around 4 times less deep than this canyon on Mars. Some scientists think that Valles Marineris is the edge of an enormous tectonic plate. It moves so slowly that almost nothing has happened in that region over millions of years, and the movement of this plate probably began 3.5 billion years ago. Anyway, the only thing left on your today's to-do list is to visit Mars's moons. They're among the tiniest in the solar system. Phobos is the largest of the two. It orbits a mere 3,700 miles above the surface of Mars. There's no other known moon that travels closer to its mother planet. It whips around the red planet 3 times a day, while the second moon, Deimos, needs 30 hours to complete one orbit. Phobos is getting closer and closer to Mars, about 6 feet each 100 years. Within the next 50 million years, it'll either crash into the planet or break apart and form a ring. Happy but tired, you return to your spaceship. Tomorrow, you'll continue exploring the magnificent red planet, and who knows what discoveries are awaiting you.
It's the year 2031, and the first human has just set foot on the red surface of Mars. It was a long flight that lasted 172 days. It was a tough journey. There were a lot of technical issues. There were some physiological obstacles. Astronauts had to deliver tons of equipment and energy-generating life support systems to the red planet. Those responsible for the mission had to understand how to deal with low-pressure atmosphere and catastrophic sandstorms, how to keep people safe on Mars' surface, and how to bring them back to Earth after the work is done. It does sound like a science fiction story, but soon it's going to be our reality. But the coolest thing? It's not the limit. After exploring Mars, people might set even more ambitious goals, and this is what some of them may look like. The next planet to visit could be Venus, but it would be a challenging task. Venus is also called the morning or evening star, all because it shines so brightly in Earth's sky that it's the first one to appear after sunset and the last one to vanish after sunrise. But in terms of exploration, Venus is very unfriendly to humans. Its atmosphere pressure is about 92 times as great as the pressure on Earth. And the temperatures on its surface are, on average, 850 degrees Fahrenheit. Modern technologies wouldn't allow us to build an infrastructure that would allow people to survive on the planet for longer than a couple of minutes. But then, why would we set sail for Venus? Here's a curious thing. At the height of 30 to 40 miles above the surface of the planet, there are the most Earth-like conditions in the entire solar system. The pressure there is almost the same as in the mountains on Earth, and the temperatures range from 70 to 85 degrees Fahrenheit. If the planet's atmosphere was made up of oxygen and non-toxic gases, we could live there without any additional equipment. Or we could go to Phobos and Deimos. Those are Mars's moons. It would be the first time humans set foot on the moon of some other planet. Phobos is located a mere 3,700 miles away from the surface of the red planet. It would take no longer than a day to reach it. This potato-shaped piece of rock is quite small, a mere 13 miles across. This is the reason why it has a very weak gravity. Deimos is a bit farther away from Mars, about 15,000 miles, but this mini-moon is even smaller than Phobos. It's a bit more than 7 miles across. In other words, visiting these moons wouldn't be unlike landing on an asteroid, and the greatest challenge astronauts would face would be leaving the surface of Mars. To do it, they would need loads of fuel. So, most likely, the first trips to Phobos and Deimos would be launched from space stations orbiting Mars. We could set an even more ambitious goal and head for Jupiter and its moons. The distance between this gas giant and our home planet is 365 to 600 million miles. This distance can be so different because the planets follow their elliptical orbits around the Sun, getting closer then further apart. The minimal distance occurs every 13 months. If people set off on this long journey during this period of time, it would still take them about 2 years to get there. Since Jupiter is mostly gas, on-planet exploration wouldn't be possible. We could probably fly around the largest planet in the solar system and even dive into its atmosphere. But much more interesting for exploration objects would be Jupiter's moons. Let's say Europa. This natural satellite has a water ice crust. It can be from 10 to 15 miles thick. Under this crust, there might be liquid water. The core of the moon might consist of liquid metal inside a rocky shell. Its super thin atmosphere contains some oxygen. Considering all this, it would be a rather comfortable place for people to explore, if not for its temperature. It doesn't rise above -240 degrees Fahrenheit. We could visit another of Jupiter's moons. That's called Ganymede. It's an ice satellite with a very thin atmosphere that contains oxygen. Or Callisto. It's the second largest among Jupiter's moons. Its icy crust is about 124 miles thick, and it's very cold on the moon, around -220 degrees Fahrenheit. People could also send an expedition to Saturn and its moons, for example, Titan or Rhea. The gas giant itself is twice as far away from Earth as Jupiter. It means it would take astronauts more than 3 years to get to this planet. But if the spaceship was launched from a space station on Mars, it could reduce the travel time by 25 to 50%. But even if the starting point of this expedition was Earth, with advanced technologies like nuclear thermal propulsion, such a journey could take a year or even less. Saturn can't be explored directly, so researchers would probably start with its largest moon, Titan. It's also the second largest moon in the solar system. This natural satellite has an atmosphere that mostly consists of nitrogen. The pressure on its surface is twice higher than that on Earth. There are winds and rain on Titan, lakes and rivers, but those consist of liquid ethane and methane rather than water. It's actually a good thing. We'd have a lot of resources to produce fuel and energy. Rhea is the second largest of Saturn's moons. It's made up mostly of water ice. Its atmosphere is super thin, but it also has some oxygen in it. Actually, all the largest moons of Saturn have only one serious drawback. It's freezing cold there. On the bright side, they all have plenty of resources to produce energy and other life-sustaining elements. And it would be much easier and faster than the same process on Mars. But what if we could explore exoplanets? Those are planets that travel outside our solar system. If we manage to get so far away from Earth, maybe we could reach some potentially habitable worlds. It could be Proxima Centauri b. It's the closest to Earth exoplanet, And recently, astronomers have found out that this world might resemble Earth even more than they previously thought. It's only 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri b is in the middle of the star's habitable zone. This means that the chances are liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. It means one of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere. It's traveling too close to its star, so the radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri b isn't likely to have liquid water on its surface. It would take way longer to reach potentially habitable Gliese 832c. This exoplanet is 16 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. Gliese 832c is 5 times as massive as Earth and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this parent star is a red dwarf, it's much cooler and dimmer than the Sun, so Gliese 832c gets as much light and heat as our planet does. At the same time, it's still unclear if Gliese 832c is similar to Earth. It probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that, unfortunately, Gliese 832c is more likely to resemble scorching hot Venus rather than relatively cool Earth. Mars is the Earth's space cousin. It's the 4th planet in our solar system, about half the size of the Earth. It also has 2 small moon buddies, Phobos and Deimos. These moons are shaped like potatoes. Phobos is the drama king, moving closer to Mars and planning a crash landing in about 50 million years. Deimos is much calmer though, hanging out farther away from Mars. Mars got a cool nickname, the Red Planet, thanks to its rusty red surface. This color was so bright that it was spotted by astronomers many years ago. Even you can sometimes see it in the sky with the naked eye, a small scarlet dot. And maybe it has hot vibes. But in reality, Mars is a very cold desert. The temperatures there can drop as low as minus 240 degrees Fahrenheit. But was Mars always nothing more than a rusty-looking desert? Actually, no. Scientists believe that perhaps many years ago, this planet was similar to ours. Meet Curiosity, the detective rover made by NASA's Jet Propulsion Laboratory. Scientists want to know all about the Martian weather, landscape, and other stuff like that. Curiosity is a pretty heavy car-sized robot. It weighs about 1,985 pounds. It embarked on its journey on November 26, 2011. The rover pulled off a landing on Mars on August 6, 2012. Originally, Curiosity's mission was supposed to last for 2 years, but it's still going strong. Curiosity is basically a space lab on wheels. It's packed with cameras, spectrometers, radiation detectors, and sensors to sniff out the Martian environment. As Curiosity roams around, it rewinds Mars history. And during its mission, the rover discovered something incredible: signs of lakes and rivers from long ago. You see, Curiosity's favorite spot to play around is Gale Crater. It's a prehistoric Martian oasis where water might have hung out. There's this huge mountain in the middle called Mount Sharp. This place is taller than 10 Eiffel Towers stacked on top of each other. And it's got layers of rocks that hold Mars's ancient secrets. Recently, scientists spotted something great when studying Curiosity's data: mud tracks. What's so surprising about that? Well, these aren't just any old tracks. They're like messages from the past. They mean that the Martian ground used to get wet and then dry out again. The mud on the ground would shrink and crack during the drying phases, making these T-shaped junctions. Moreover, it seems like the ground on Mars went through several wet-dry cycles. It happened maybe up to 10 times. This made the junctions turn into Y-shaped cracks. When a bunch of Y-shaped cracks got together, they made a super cool pattern, something like a patchwork of hexagons. It looks just like honeycombs, or even a dragon's skin. Each of these hexagons are the size of candy. Similar cycles have happened on Earth, and they're linked to the birth of life. When water dries up, it leaves behind concentrated stuff that's great for chemical reactions, and these reactions might be the same ones that kickstart life. These hexagons have been hanging around for a really, really long time, billions of years. That means that Mars once had a climate kind of like Earth's, and maybe even life. In fact, the red planet even has some signs of water right now, in the form of hidden ice at the poles. Mars has the North and South poles, and just like with the Earth, they're red planet's ice caps. Picture the North Cap as a big, icy pancake about 620 miles wide. The South Cap is a bit smaller, about 220 miles wide, but it's got a thicker ice layer, almost like a snowball with a strong shell. When it's winter at the poles, it's an incredibly long nighttime. No sunlight, just chilly darkness. During that time, around 30% of the air turns into frozen CO2. It's dry ice, the same stuff that's often used in horror movies. But when the poles wake up to sunlight, the dry ice turns back into gas. All this freezing and thawing makes clouds and frost, just like on Earth. One time, a rover named Opportunity even caught some clouds made of water ice. But it doesn't necessarily mean Mars was once thriving just like the Earth. Life needs more than just wet, dry cycles to pop up. It needs the right atmosphere and other special ingredients. We're not sure if Mars had all of those, and even if it did, there's no guarantee that life actually happened. But this raises another very important question. Has Mars ever hosted tiny living creatures? Curiosity isn't the only robot that tries to find the answer to that. There's also a rover called Perseverance. It's trying to find clues about Martian life. It's digging into an old Martian crater once filled with water. And like a space archaeologist, Perseverance is searching for fossilized signs of ancient critters. And here's the funny thing. Some scientists think that we've stumbled upon it almost half a century ago. The only problem is, we might have accidentally destroyed it. It happened even before Curiosity started rolling around Mars. Back in the 1980s, two cool NASA's landers, Viking 1 and Viking 2, made a pit stop on the red planet. These landers took a selfie, and then they also did some funky experiments on the Martian soil, all in the name of finding signs of life. What they found is some weird organic stuff called perchlorate. It's a compound that we use in fireworks or rocket fuel. But most results didn't seem that promising. They even mixed up some soil with water and nutrients, hoping that if there were Martian microbes, they'd snack on the goodies and return radioactive gas as a result. But unfortunately, that didn't happen. Now, here's the problem. Some scientists think that maybe the water they added back then actually destroyed those tiny Martian critters. Poor microbes were just hanging out and suddenly got soaked by a bunch of weird liquid. Something like this wouldn't be very pleasant for the Earth microbes. They live inside rocks and they're sucking water from the air. Pouring water on them would result in a total disaster. So, of course, giving them nutrients after that wouldn't do anything. If you've just barely survived a water bath, you're probably not in the mood for a feast. Perhaps these Martian buddies might have something called hydrogen peroxide in their cells. It helps them live in an extreme environment. If that's true, it could explain all the results from the experiments. You see, the instruments heated up the samples, so if there was hydrogen peroxide, it would have gone boom, wiping off the little guys and turning their cozy homes instantly. Imagine how ridiculous it would be if it turns out that we accidentally destroyed the only signs of life on Mars. Ideally, we need a new mission to Mars to test this theory. Let's hope it's not true. In any case, the journey isn't over. There are more missions planned for Mars, and humans might even visit this planet someday. The next mission is the Mars Sample Return. It's a super cool teamwork project between NASA and ESA. They're teaming up to bring back souvenirs from Mars, collected by NASA's trusty Mars Perseverance rover. There's going to be a whole bunch of spaceships, they'll work together to bring these precious Mars samples back. The samples are planned to arrive on Earth in the early to mid-2030s. And the fun doesn't stop at Mars. Our Mars missions are a warm-up for an even bigger adventure, exploring icy moons around Saturn and Jupiter. These moons have hidden oceans beneath their icy surfaces, and who knows what kinds of space secrets they're hiding. But whether it's Mars, icy moons, or beyond, our quest to find extraterrestrial life continues. In addition, we are slowly starting to find more and more organic materials on Mars, and maybe one day we'll finally find some microbes in our solar system. Let's hope for it and stay tuned.
What a nice cosmic family. Meet Mars. I bet you've met him before. These two little guys are Phobos and Deimos, Mars's small moons. But it seems like Mars isn't treating the little ones the right way. Phobos and Deimos are believed to be captured asteroids. However, Phobos is gradually moving closer to Mars due to gravity, and it is predicted that it will eventually be destroyed by the planet's gravity within the next 35 million years. I won't be around then. So, I imagine this will result in a ring of debris around Mars, similar to Saturn's rings. However, this process is a natural phenomenon and not an act of destruction by Mars. Apparently, Phobos is getting ripped apart by the crazy gravitational forces of the red planet. But wait, there's more! Phobos has these crazy parallel grooves all over its surface. We used to think that they were from an asteroid crash, but now scientists think they're actually from Mars's intense gravity pulling the moon apart. Talk about a rough ride! Scientists have this wild idea that when a little guy like Phobos gets too close to a big guy like Mars, it starts to stretch out towards it. They call it the tidal force. Phobos is predicted to get stretched out so much that it'll actually break apart. Crazy, right? And the debris from the moon will form a tiny ring around Mars, just like Saturn's rings. Now, some people thought that Phobos' tiger stripes were caused by tidal forces before, but that theory got shut down because the moon is just too darn fluffy. But now, these genius researchers ran some computer simulations and found out that maybe there's a hard shell underneath all that fluff that could create grooves on the surface. But don't worry. At the rate Phobos is going, it's going to crash into Mars in about 40 million years. But if tidal forces are already tearing it apart, it might not even last that long. However, we'll still have the chance to learn more about Phobos. NASA just picked 10 rockstar researchers from all over the U.S. to join the science working team for JAXA's Martian Moons Exploration, or just MMX mission. As NASA-supported participating scientists, they'll be helping JAXA explore the two Martian moons, Phobos and Deimos. And get this, they're even planning to land on Phobos and grab a surface sample. The mission is set to launch in 2024, and we'll get our hands on that sample in 2029. 7 of the lucky researchers will be using the MMX flight instruments to conduct their research. Phobos is a real oddball. It's only 17 miles wide and orbits Mars at a distance of 3,728 miles, to be precise. Now that's way closer than Earth's moon, which takes a whole 27 days to orbit us. But Phobos is in a death spiral toward Mars and is slowly falling towards the planet's surface at a rate of 6 feet every 100 years. But there must be a reason why Mars is acting that nastily, right? What if it's all just because of plain vengeance? Well, okay, picture this. Mars is minding its own business, being all hot and watery like a young Earth. It's got a sweet magnetic field that's protecting it from cosmic radiation and keeping its atmosphere nice and thick. Hey, life is good. But then, at least 20 asteroids, each the size of a small country, come crashing down on Mars like a giant game of cosmic whack-a-mole. One of them even leaves a crater that's almost 2,000 miles wide. Now imagine how Mars must feel with 2 asteroids being its moons after what other asteroids did to the red planet. All these impacts are like a massive punch to Mars's gut, and its already weak magnetic field is knocked out cold. The core gets all overheated and can't circulate properly, which means no more magnetic field to protect the planet. It's like as if you were wearing nothing at the depth of the Mariana Trench. If it were possible, you'd be defenseless and chilly. It's basically what happened to Mars. So now, poor Mars is out there in the cold, unprotected from all those nasty cosmic rays. It's like going outside without sunscreen, not a good idea. But at least we can learn from Mars's mistakes and make sure Earth doesn't have the same fate. Maybe we should start investing in some asteroid insurance. But trust me, the red planet isn't mean at all. It's actually pretty friendly. While Mars may seem to be pretty tough for Phobos, there's something that might be thriving with Mars's help. So get this, a team of scientists found a way to grow rice on Mars. Yep, you heard me right. They used MMS, not the outdated way to send pictures, but a special soil called Mojave Mars Simulant. It's supposed to mimic Martian soil. And here's the catch, Martian soil has these nasty percolate salts that can be toxic for plants. So the team grew 3 types of rice, 1 normal and 2 gene-edited with mutations that make them better at handling stress like drought or salinity. And guess what? The mutant strains were able to root in soil with 1 gram of percolate per kilometer. Take that, Martian soil. But hold up. The rice grown in the MMS didn't turn out as great as the ones grown in regular potting soil. So the team decided to mix a quarter of the potting soil with the Martian simulant, and looky there, the plants started developing better. Now these scientists aren't just thinking about feeding Martians. They also want to see if their findings can help grow crops in places on Earth with high salinity. And get this, the whole project started when 2 researchers met for coffee and decided to try growing plants together. Well, isn't that nice? I suspect you're about to say, hey, but if you want to grow rice on Mars, you'll have to ship insane amounts of water from Earth, and it's not easy to quench this plant's thirst. You're right. You need about 449 gallons of water to only grow a pound of rice. But guess what? Scientists made a groundbreaking announcement at the Lunar and Planetary Science Conference in Texas. They found a relic glacier near Mars's equator. That's right, water ice on Mars, even near the equator. This is huge news, and could mean there's even more ice just below the surface. It's not just any glacier, it's a relic glacier that's estimated to be 3.5 miles long and up to 2.5 miles wide. It's like the size of a small town. It's got all the features of a glacier, including crevasse fields and moraine bands. But get this, it's not actually ice. It's a salt deposit that formed on top of the glacier while preserving its shape. So, how did this salt deposit form? Well, it turns out that volcanic materials blanketing the region might have something to do with it. When these materials come into contact with water ice, sulfate salts may form and build up into a hardened, crusty layer. Over time, erosion removed the volcanic materials, exposing the sulfates and revealing the glacier's unique features. This glacier is young, likely from the Amazonian geologic period. That means that Mars has had surface ice in recent times. Who knows what other icy secrets Mars is hiding? But hold your horses, there's still more research to be done. Scientists need to figure out if there's still water ice preserved underneath the salt deposit, or if it has disappeared entirely. And if there is still water ice at shallow depths near the equator, that could have major implications for human exploration. Imagine being able to extract water from the ground at a warmer location. That would be a game changer. So let's see what else these scientists uncover about our favorite red neighbor. Maybe someday we'll even get to visit that salt glacier statue in person. See you next time.
NASA made this cool rover called Curiosity and sent it to Mars to see what else we can find out about the red planet, the one that will possibly become our next home. Curiosity has been exploring the surface of Mars, taking measurements and gathering data about the planet for more than 10 years. And good old Curiosity stumbled upon some interesting wave-rippled rocks in the region of the Martian surface that was kind of expected to be drier. Scientists believe this area was actually a lake bed. It might be the bottom of a dried-up lake and all that sediment and other things that have accumulated there. All this can give us some important clues about the history of the lake. For instance, the types of organisms that might have lived there, how deep the lake was, how long it was there, and similar stuff. These wave-rippled patterns tell us that these rocks may have formed when strong Martian winds were moving the water in this big ancient lake. You know that specific sound you can hear when you're holding a seashell to your ear? You actually hear it because of the way the air gets trapped inside the shell and moves against its walls. The air cannot escape, so it vibrates at frequencies that depend on the size of the shell. In other words, you have a feeling you hear the sound of waves hitting a shore. That's Mars in my imagination now, a spot where you can still hear the long-lost sound of waves crashing against the shores of mysterious gigantic lakes. During its mission, Curiosity also came across a metallic object which turned out to be a meteorite. This unusual rock that came from space is made of nickel and iron. Its name is Cacao, and it's about the size of a small car, 6.5 feet long, and weighs over a ton. This is an important discovery because we don't often find metallic objects on the Martian surface. Most of the rocks there are made of basalt or some other volcanic materials, so that chunk of metal could tell us more about the history of Mars and how it formed. Plus, it definitely stands out. The surface of Mars is red from oxides, while Cacao is metallic-looking and dark gray. It's rounded and smooth, too, which means it once passed through Mars's atmosphere. There have been other robots exploring Mars, too. For instance, NASA's Mars Reconnaissance Orbiter, MRO, stumbled upon circular sand dunes. Sand dunes are usually very common on the red planet. They come in many different shapes and sizes, but circular ones like these are really rare. They consist of dark sand with light-colored material surrounding them. And the cool thing is that these dunes are arranged in a specific pattern, similar to the spokes of a wheel. It could be because of the way the winds blow. But back to our buddy, Curiosity. It's been exploring many other interesting things, like oxygen levels in the Martian atmosphere. The levels change depending on the season. There's more oxygen in the spring and summer. It's still not clear why, though, and of course, even that is not enough for us to really breathe there. The concentration of oxygen on Mars is 0.1%, which is about 100 times less than the concentration in Earth's atmosphere. The atmosphere of Mars is mostly made up of carbon dioxide, with traces of other gases. Curiosity was so good that it also decided to analyze the age of rocks it found. It seems they're much older than we previously thought. Some of them date back more than 3 billion years. Curiosity found organic molecules in soil samples too. These molecules are basically building blocks of life. Now, this doesn't prove there's indeed life on Mars. It's just one of the things that suggests there might have been some form of life a long time ago. Curiosity discovered potential evidence that there might be a large reservoir of liquid water beneath the south polar ice cap, probably very salty and full of different minerals. This high salinity is the reason why this water could remain liquid at temperatures well below freezing. It would be cool to have some sort of subsurface ocean to take a dip in, especially when these crazy Martian winds are raging on the surface. And it would be great to have something that would protect us from those insane radiation levels on the red planet. There are some pretty toxic chemicals and salts in the Martian soil, which can be really bad for humans. Astronauts could potentially end up being exposed to these toxic chemicals, either through direct contact with the soil or by inhaling dust that contains these salts. Also, these substances could be a problem for growing crops. This is a really big discovery for long-term missions to Mars, because astronauts would need to be able to grow their own food so they can survive while there. Another thing that favors the idea of potential life on Mars is discovering methane there. Methane is a very important finding because usually living organisms produce this gas. So, where did it come from if not from them? In reality, There are a few possible explanations for that. One is the geological activity of underground reservoirs. Another idea is that meteorites brought methane to the red planet. What's interesting is that levels of methane are higher in particular areas. So yeah, I don't know about you, but I'll stick to the theory that it comes from living organisms. Now, it's possible that volcanoes on Mars are still active. We know there are many extinct volcanoes on the red planet, but we've never found enough evidence to prove that some of them are still alive. Scientists studied volcanic deposits and found out that some volcanoes could have erupted maybe 50,000 years ago. Before that, everyone thought the last eruption happened 3 to 4 billion years ago. If you could compress the geological history of Mars into just one day, this would be like having an eruption a second ago. So, you never know. There might still be magma bubbling in secret under the Martian surface. All the future generations that might end up building their life there could really have some fun. Mars turned into a cold and barren place that can't really support life over time. And one of the main reasons for that was losing its atmosphere. The red planet used to have a much thicker atmosphere, similar to Earth's. One major reason for that is its relatively weak magnetic field. Earth's magnetic field helps protect our atmosphere from the solar wind, a stream of charged particles that comes from the sun. Without this protection, Mars had nothing to help it confront this insanely strong force that eventually took away most of its atmosphere. Another factor that played a big role in the loss of Mars's atmosphere is its relatively low gravity. Because Mars has weaker gravity than Earth, it's easier for gas molecules to escape into space. So Mars probably used to be more similar to our home planet. But with its current thin atmosphere, it can't keep any heat, which makes it very cold and very complicated for us to explore. But maybe it's better for us that we didn't visit the red planet back in its old times. There's this story about an ancient megaflood that might have happened there. So yes, the red planet probably used to be a wetter and more hospitable place than it is today, with beautiful flowing rivers and amazing lakes, ponds, and other bodies of water. And some research showed evidence of large channels carved into the planet's surface. These channels are way bigger than any we previously found on the planet. They suggest this megaflood happened billions of years ago. Perhaps it happened as a result of different factors, like volcanic activity, melting ice, and the release of carbon dioxide from the planet's crust. The flood may have created some temporary pools of water, too. Hopefully, it will mean more interesting clues for finding traces of microbial life. How about that? Like the little engine that could, NASA's Curiosity rover has been bravely crawling over Gale Crater on Mars, trying to see what could have happened billions of years ago that made the planet a red desert. And it looks like it might have finally stumbled upon something. While life seems impossible on Mars now, eons ago, it may have been a world more like Earth, with a thick atmosphere, water, and maybe even life. And it seems things changed just recently. Studies show that just 3 billion years ago, the northern hemisphere of Mars might have hosted a stable ocean. On Earth, the Archean eon was in full swing. Volcanoes were going crazy, and life was taking its first steps. Life was also perhaps taking its first steps on Mars. No, not a frozen wasteland like Antarctica, but in a body of water like an Earth ocean. And this Earth-like climate extended Mars's habitable period by about 500 million years more than we thought before. In other words, there was a 500 million years where it was exactly like Earth, with conditions just right for life to start forming. But then, something happened that changed things forever. The atmosphere thinned, Mars lost its oceans, and became the cold, desolate place we see today. It's been a mystery for a while, but now, Curiosity stumbled upon something interesting in the Gale Crater, a vast basin on the Martian surface where, billions of years ago, water once flowed freely. It found carbonates, stuff that can tell us all about the ancient Martian climate.
There are minerals that form when carbon dioxide, or CO2, dissolves in water, which means that, to create them, you need two things: a nice thick atmosphere and liquid water. Now on Earth, CO2 is super important because it helps trap heat from the sun in our atmosphere. This keeps our planet warm enough to support life. Plants eat it during photosynthesis to create oxygen, which humans and animals need to breathe. On Mars, the presence of CO2 shows that there really was some kind of climate system. When CO2 starts dissolving in water, it reacts with certain minerals in the ground, like calcium or magnesium, and creates carbonates. That's kind of how seashells form in oceans here on Earth. But instead, it's happening with rocks on Mars. And this discovery is huge. These carbonates act like fossils of the planet's ancient climate. They store information about what Mars was like long ago. By studying them, scientists can get a peek into Mars' past back in the day when water was present. They can tell us how the Martian atmosphere has changed over time, show whether the atmosphere was warm or cold, or if there was a lot of water around, and what happened to the planet in general. Luckily, Curiosity can study this stuff right there. It has the sample analysis at Mars and tunable laser spectrometer. Those are like Mars's forensic tools. The SAM is a mini lab on wheels, and is capable of heating Martian rock samples to extreme temperatures. There are two ovens that can heat samples to about 1,800 degrees Fahrenheit. This intense heat causes rocks to release gases trapped inside, the ones that are like ancient fingerprints of Mars, atmosphere. Once they're released, the TLS analyzes them in detail, breaking them down to the tiniest parts. And what the scientists discovered blew away all our previous assumptions about Mars' habitability. Turns out, it's not just about Mars once being wet, but there was something that led to the gradual drying and cooling of the planet. In other words, Mars's water didn't just disappear. It evaporated quickly under extreme conditions. So, what happened to it? Astronomers produced two possible explanations. The first one says that Mars went through periods where it was sometimes wet and sometimes dry. The water didn't last a long time. It may have appeared in short bursts, with periods where it would dry up and then return. The second possibility is more intense. The water that was there was incredibly salty and cold, so instead of being liquid, it was mostly frozen in ice. This would have made the planet way too harsh for life as we know it, since the conditions would have been too extreme for anything to survive. Both possibilities sadly mean that Mars wasn't cozy and full of life in the past like some hope. Well, at least not on the surface. That doesn't mean underground life couldn't exist though. This one is still a possibility. And to find more, we must keep looking for hints of water now. Actually, after years of exploring Mars, scientists have just made a mind-blowing discovery. Deep beneath the rocky surface of the red planet lies a hidden reservoir of liquid water. Real water this time, not the frozen ice caps or vapor in the atmosphere, though it's miles below the Martian crust. This breakthrough comes from data collected by NASA's InSight lander. This guy spent 4 years listening to the subtle tremors of Mars. You know, Mars quakes. And it analyzed over 1,300 of them. Thanks to this, scientists were able to map out how seismic waves move through the planet, and it revealed pockets of liquid water buried 6 to 12 miles underground. Not just one lake, but puddles. So they used the same methods we here on Earth use to find underground water, oil, and gas. And they were able to piece together the Martian underground system. You see, as the water disappeared and dried out, some of it escaped into space when Mars lost its thick protective atmosphere. However, this discovery shows that much of the water didn't disappear. It just sank deep underground, where it still lies today. So close, but out of reach. That's a huge step forward. Water is the most important molecule when it comes to shaping the destiny of a planet. And also, even though we said that Mars wasn't filled with life before, this doesn't take away the possibility of it having life now. If liquid water still exists deep underground, could there be some little microbes hiding there as well? Life as we know it can't survive without liquid water. And now, with this, the idea of life on Mars has become more plausible than ever. There's a catch, though. While this water may seem like a jackpot to future Mars colonization plans, it's not going to be easy to reach. To say that drilling 6 miles deep into the crust is no small feat is an understatement. Just so you know, here on Earth, the deepest we've drilled is about 7.5 miles. It was in the Kola Super Deep Borehole project. And this project pushed current technology to its limits. Intense heat, pressure, equipment failures, you name it. With Mars, that would be even crazier. It has a much colder environment, extremely thin atmosphere, and lack of infrastructure. That would make any drilling mission extremely difficult. To reach water reservoirs buried so deep on Mars, we would need specialized drilling equipment that would somehow get delivered there. It should also be able to handle extreme cold, low pressure, and different gravity. Oh, and it should all operate remotely and preferably not break, all while it needs tons of energy. Yeah. Now, it's possible that we would only be able to do this in the future when we'll have automated systems or astronauts on Mars. That's not a quick task for even the most ambitious billionaires. So, for now, what these reservoirs hide is a mystery. But at least it's not the only one. As we mentioned, Mars hides one of the greatest secrets beneath its frozen southern pole, another buried vast lake of liquid water. The radar revealed it as it scanned the ice cap in this region. Hey, just don't make me pronounce it. Now, it's weird that it managed to stay liquid with such low temperatures. It's probably because of the geothermal heat beneath Mars' surface, and life could be there too. So now they're thinking about probing this lake first. That would be much easier. Curiosity's work is incredible, and it keeps helping us peel back the layers of Mars' ancient climate, giving us new pieces to the puzzle of what happened to our neighbor. And this could help us avoid similar mistakes in the future.
On the 30th of May, 2024, scientists made a shocking discovery. A rock that cracked open after NASA's Curiosity Mars rover drove over it revealed yellow sulfur crystals. It was something never seen on the red planet before. Starting from October 2023, Curiosity has been exploring an area rich in sulfates. That's a kind of salt that forms when water evaporates and contains sulfur. But in the past, all discovered rocks only had mixes of sulfur and other materials, while the rock found by the rover is made of pure sulfur. Now, most people associate sulfur with that yucky stench of rotten eggs, but in reality, elemental sulfur doesn't have any smell. It forms pretty rarely and needs very particular conditions. And scientists have never associated such conditions with that very location on the red planet. Now, guess what? Curiosity then found an entire field of bright rocks similar to the one it had crashed, made of pure sulfur. Specialists explain that it's something that shouldn't be there. So now, they have to find a way to explain this phenomenon. It's just one of a few interesting findings Curiosity has made during its exploration of the Geddes Vallis Channel. That's a groove running down a slope of 3-mile-tall Mount Sharp. The rover has been ascending the base of this mountain since 2014. Each layer of the mountain represents a certain period of the history of the red planet. And the main mission of Curiosity is to figure out when and where ancient Martian terrain could have provided nutrients for microbial life. Geddes Vallis had been spotted from space years before Curiosity was launched. This channel became one of the main reasons scientists wanted to visit this part of Mars. They believe that the channel might have been carved by flows of liquid water and debris. They supposedly left a ridge of boulders and sediment going 2 miles down the mountslide below the channel. Since Curiosity arrived at the channel earlier this year, researchers have been trying to figure out whether landslides or ancient floodwaters built up the large piles of debris rising from the channel's floor. The latest data from Curiosity hints that both factors played their own roles in this process. Some mounds look as if they were left by wild flows of water and debris, and others seem to result from local landslides. The thing is, stones carried by water flows got rounded like river rocks, and angular rocks are likely to have been deposited by dry avalanches. One more detail: water soaked all the material that settled in that area, and the resulting chemical reactions bleached white halo shapes into some rocks. Over time, wind and sand erosion revealed those shapes. Researchers say that the period when it was all happening wasn't a quiet one for Mars. There was an astonishing amount of activity there. Multiple flows down the channel included severe floods and boulder-rich flows. All this evidence of water tells a more complex story than what scientists expected to find in that region. That's why they've been so eager to lay their hands on a rock sample from the channel. It would let them learn more about the history of that area. Well, on the 18th of June, they got their chance. The sulfur rocks were tiny and brittle, so they couldn't be sampled using the drill. But nearby, Curiosity found a large rock that was later nicknamed Mammoth Lakes. Rover engineers had to look for a part of the rock that could allow safe drilling. Luckily, there was a suitable parking spot on the loose, sloping surface of the rock. Curiosity bored its 41st hole with the help of a powerful drill. Then, the rover trickled the powderized rock into its belly for further analysis. This way, scientists will be able to figure out what material the rock was made of. Curiosity has already moved away from Mammoth Lakes. Now, the rover is off to search for other surprises the channel has prepared for us Earthlings.
Jupiter has 79 known moons, and the 4 biggest of them that are particularly interesting are Galilean moons. They were named after Galileo Galilei. He discovered them in the 17th century. They have something in common, but at the same time are all very different. Europa is the smallest of the Galilean moons with a diameter of 1,860 miles. It orbits Jupiter every 3.5 days. The first images we got from there were taken in the 1970s. Its surface mostly consists of water ice. Europa has long fractures, often around a mile wide, that can extend for thousands of miles across its surface. They were probably formed as the crust pulled apart from tidal forces on the mysterious ocean beneath the surface. In 2012, scientists discovered water vapor plumes erupting close to its south pole, rising up to 125 miles. These plumes can help us find what's inside Europa without having to land there. Scientists think there could be a magnificent ocean hidden 10 to 15 miles beneath the solid surface. That ocean could be 40 to 100 miles deep. Even though it's just 1/4 of Earth's diameter, it contains twice as much water as all of our oceans together. This ocean is a potential environment for some forms of life. Scientists believe the entire ice crust is floating on that ocean. It probably makes a full rotation around Europa once every 12,000 years. In the image the Galileo spacecraft took, you can see small dark brown spots. They're 6 miles across and formed as the hot, less dense material was getting to the surface. It either pushed the crust or broke through it altogether. The surface of Europa consists of so-called chaos terrains. They're rough areas surrounded by a smoother surface. Its equator could be covered in ice spikes called penitentes that can go up to 50 feet high. We have them on Earth too, especially in dry areas at high altitudes. But none of them are as big as those on Europa. Our moon has over 5,000 big craters with a diameter of more than 15 miles. Europa's surface lacks impact craters and doesn't look like it's more than 50 million years old. This means the surface of Europa is changing and reforming all the time. This moon is icy and is one of the smoothest of any solid space objects in our solar system. Because of it, it's 5 times brighter than our moon. Europa is under a constant blast of radiation coming from Jupiter. It's so strong, we wouldn't last even a day there. Europa is 5 times further away from the center of our solar system than Earth. That means it barely gets any heat coming from the sun, so it can remain frozen since the average temperature is negative 250 degrees Fahrenheit at the equator and around negative 360 degrees Fahrenheit at the poles. About 40 years ago, the Voyager 1 spacecraft came close to the rocky moon Io and discovered that it's a volcanic champion of our solar system. Io is Jupiter's 5th innermost moon. 4.5 billion years old, nearly the same age as Jupiter itself. It's similar in size to our moon, and even has a similar density and amount of gravity. Many moons in our solar system consist of silicates and water ice, but Io is made of iron and silicate rock. You'd be able to see some beautiful auroras on Io. As this moon rotates around Jupiter, auroras change brightness all the time, but they're always there. Io is relatively close to Jupiter, almost 260,000 miles above its cloud tops. If you could come to Io and take a look at Jupiter from there, it would appear almost 40 times bigger in the sky than our moon. Stargazing there would be amazing. Io needs 42.5 hours to orbit Jupiter. Our moon needs almost a month. At some points, Io's tidal bulge can go up to 330 feet. It's similar to what we have on Earth. The gravity of our moon causes ocean tides. Io doesn't have an ocean, but the ground itself moves and goes up and down. It's like an elevator taking you to the bottom and then the top of a building with 30 stories. The gravity of Jupiter and its other big moons affect Io, so the solid ground tides on its surface are over 5 times as high as the highest ocean tides on our planet. All this makes Io so hot on the inside that some of the inner materials melt, boil, and try to escape in any way possible. Eventually, it creates a hole in the ground, which then turns into a volcano. Io is the most active body in our solar system when it comes to volcanoes. Io has more than 400 of those, with 150 of them erupting all the time. Some of them shoot their hot gas plumes 200 miles into space. It would be difficult to walk there because we're talking about a pretty intense world of floodplains of liquid rock, huge lava flows, multiple lava lakes, and giant collapsing mountains. Ganymede, the largest moon in the solar system we know of, also has the biggest water ocean. It's 26% greater than Mercury when it comes to volume, but it's less dense. This giant moon has a thick crust of water ice 90 miles deep. There might be a huge ocean of liquid water underneath. It extends 60 miles deep, which is about 10 times deeper than the deepest point in the Earth's ocean. The Voyager spacecraft also detected polar caps made of water frost there. Ganymede is half rock, half water, including tiny amounts of metals and ice. Its atmosphere is very thin and doesn't contain oxygen. This ocean most likely doesn't contain life. The Earth is a great example of how certain microbes and creatures can survive deep down without sunlight. But the ocean of Ganymede is so deep and the pressure is so strong that the water at the bottom is probably compressed back into ice. Certain forms of life in the deepest areas of our ocean survive thanks to geothermal vents that eject minerals. Since there's likely thick ice between the ocean and the core, this isn't the case with Ganymede. But the ocean there is salty, with multiple layers divided by icy sheets. If there's any chance of life, it could be in the part where the rocky core is in contact with the most internal icy layer. Beneath all that water and ice, Ganymede is the only moon in the entire solar system with a magnetic field. It's possible because this moon has a liquid core. Ganymede circles Jupiter approximately once every 7 days. Its orbit is so eccentric that at some points, it's pretty close to Jupiter. Ganymede, Io, and Europa have gravitational forces that affect each other. In the time Ganymede orbits Jupiter once, Europa makes 2 orbits, and Io makes a full circle 4 times. 1/3 of Ganymede's surface contains big dark regions, while the other 2/3 are lighter. Dark areas are older and contain more craters. Lighter areas have long ridges and grooves, about 2,300 feet high and thousands of miles long. Callisto, the 3rd biggest moon in the solar system, 3,000 miles in diameter, needs 17 Earth days to orbit Jupiter. Its atmosphere is very thin. There are many impact craters, but its ancient crust has basically been the same for more than 4 billion years. When a planet is geologically active, like the Earth, some things can erase most of the evidence from past impacts. water, volcanoes, tectonic plate movements, human activity, and weather. All this changes the surface. Callisto has experienced none of those. Scientists think this moon used to be an ocean world that eventually froze over. It was hit by meteors from time to time, but mainly remained untouched. And yet, it still has some pretty impressive craters, like Valhalla, the biggest multi-ring crater in our solar system. That's 2,500 miles in diameter. Major craters on Callisto contain more rings than those on other celestial bodies. Whatever hit the moon was big enough to have punctured the thin crust, causing water to spread on the surface. And under this thin crust, there could be either salty ocean or soft ice. The Galileo space probe detected that Jupiter's magnetic field couldn't penetrate through this moon, likely because of a layer at least 6 miles thick. That's why it's hard to explore Callisto. Moons like Europa have vents that eject water from the subsurface oceans. But to explore Callisto and discover more about its past, we'd have to use the old-school way, digging through the crust. If we wanted to explore the outer parts of our solar system, Callisto would be a great spot because Jupiter's radiation doesn't reach it. So we'd be safer there than on some other inner moons.
Under your feet, the moon is pulsing. You feel danger with every pore of your body. The lifeless satellite, or so you thought, stays still for a second before knocking you down to the ground with a powerful tremor. Is it a moonquake? For years, scientists believed the moon was completely inactive, but the newest evidence seems to suggest that this idea is totally wrong. Researchers from the University of Maryland have recently discovered 266 mysterious ridges on the far side of the moon. And these ridges likely point to recent geological activity. So, are we really talking moonquakes? Well, kind of. The ridges are located in volcanic regions that formed 3.2 to 3.6 billion years ago, but they appear much younger than expected. Typically found in clusters of 10 to 40, they're often located in areas where the moon's surface is structurally weaker. Now, when astronomers speak about recent, don't take their words literally. They don't mean last year or even decade. Most models scientists created suggested that the moon's geological activity ended 2.5 to 3 billion years ago. But the new information hints at the possibility that these formations have been active within the last billion years. Some of the smaller ridges seem to have formed as recently as 200 million years ago, and that is considered relatively young on the moon's timescale. It means that the moon may still be experiencing geological changes today. These discoveries kinda challenge our understanding of the moon's history and evolution. But how did scientists come to these conclusions anyway? Researchers from the University of Maryland and the Smithsonian Institution used crater counting to estimate the age of lunar ridges. It works like this. Surfaces with fewer craters are younger, and the more craters some region has, the older it is. Plus, the analysis showed that some ridges cut through already existing craters, meaning they likely formed around 160 million years ago. In geological terms, this is very recent, suggesting that these ridge-forming processes may still be happening. Another cool thing is that the ridges on both the near and far sides of the moon are similar, which means they may have formed through the same geological processes, having been shaped by the same forces. These forces might include the moon's gradual shrinking, thermal contraction, and shifts in its orbit. We'll talk about it a bit later. Another argument supporting the idea of a still active moon is decades-old data from the Apollo missions. They had already detected shallow moonquakes with the Apollo Lunar Seismic Experiment, recording 28 quakes ranging from magnitude 1.5 to 5. Researchers believe that these ridges may be linked to similar seismic activity. Now, about that bizarre shrinking of our natural satellite. Scientists believe the moon formed about 4.5 billion years ago when a Mars-sized object collided with early Earth. This catastrophic impact likely sent bunches of superheated material into space. Eventually, they came together and formed the Moon. In its early years, the Moon was just a molten world, shaking from intense volcanic and seismic activity. So, the Moon used to be a molten mess floating through space. But when did it actually solidify? Scientists have finally figured it out, 4.43 billion years ago. This was a huge turning point, not just for the Moon, but for Earth too. After all, the giant impact that formed the Moon might have also been the final blow that made Earth stable enough to support life. In any case, billions of years passed. The Moon gradually cooled and contracted. And now look at this modern-day rocky sphere illuminating our nights. But the Moon isn't completely rigid yet. It still keeps cooling. And this slow cooling of its core might be one possible reason for the Moon's continued activity. As it cools, the Moon's interior contracts, which leads to cracks and shifts in the crust. One of the clearest signs of this contraction is found in the lunar maria. See these large, dark patches on the Moon? Those are called maria, areas formed when lava filled ancient asteroid impact craters and then solidified. Then, over time, the cooling and contracting crust created these wrinkle ridges. Another factor of the ongoing geological activity could be the Moon's gravitational interactions with Earth. Such non-stop powerful interactions likely create surface stress and trigger tectonic movements. It's all good and exciting, but can this activity on the Moon actually affect humans? In a sense, it can. The Moon has long been seen as a stable place for future bases and resource extraction. But the discovery of this ongoing geological activity is pretty worrying. If the surface is still shifting, future settlements, infrastructure, and mining operations could face serious risks. That's why, at the moment, we need seismometers and ground-penetrating radars to better understand these movements. It will allow us to assess potential dangers before any long-term missions begin. By the way, there's another potential problem future lunar missions might have to deal with, and it's moon dust, aka regolith. Apollo astronauts quickly learned that this jagged, sticky dust gets everywhere and can damage suits, equipment, and even health. A new study from Texas A&M engineers found another problem. When rockets land or take off, they kick up regolith, which can become a collision hazard, especially with many spacecraft bringing crews and cargo to the Moon. Lunar regolith comes in all sizes, from tiny dust particles to large rocks. The main ingredient in moon dust is fine silicate materials, about 70 microns in size, like a human hair. They formed over billions of years as meteors and asteroids smashed into the Moon's surface, grinding much of it into powder. Unlike Earth, the Moon has almost no atmosphere. It's incredibly thin, so there's no wind or water to smooth out the dust. On top of that, constant exposure to solar wind has given the regolith an electrostatic charge, making it stick to anything it touches. Apollo astronauts quickly found this out the hard way. Moon dust clung to their suits, got trapped inside their landers, and stuck to everything. Worse, it became a health hazard, causing eye irritation and breathing problems inside their spacecraft. But at the moment, it seems like a problem for future us. A much more important issue is finding water to support future missions, and China is going to deal with it. It's getting ready for a big mission to look for hidden ice on the Moon. As part of the Chang'e 7 mission in 2026, a flying robot will explore deep craters at the Moon's south pole, where ice might be trapped. If they manage to confirm it, this could be a game changer for future lunar missions. Astronauts will have a water source and even fuel for space travel. The mission is a key step in China's plan to land astronauts on the Moon within 5 years. While signs of water have been found before, like in soil samples from Chang'e 5's probe and observations by NASA and Indian spacecraft, scientists believe that deep ice deposits are the real key to supporting future missions. The south pole of the Moon has some incredibly deep craters, and experts think ice could be hiding inside them. The flying robot will try to explore one or more of these craters after landing. If it does find the ice, it could make long-term moon missions much cheaper and more practical, helping astronauts live and work on the moon. Some scientists also think that this discovery could offer us some clues about extraterrestrial life. In any case, whether we find water on the moon and learn to deal with that pesky dust or not, the recent discovery of those young lunar ridges is a game changer. If the moon is still geologically active, it means we don't know as much about our closest neighbor as we thought. What else could the moon be hiding? Are we really prepared for the idea that this lifeless satellite might actually be more dynamic than we imagined? Future missions, which might not be as safe as we once believed, will probably show. Chances are, we're going to find life beyond Earth by 2035, and there's no need to travel to a galaxy far, far away. Our Milky Way galaxy is full of totally suitable environments. Don't get too hyped up though. We're talking about microbes or chemical markers, not Hollywood-like green humanoids. Even so, when we finally find traces of life, it will change how we see our place in the universe. NASA's Kepler Space Telescope discovered something incredible. Almost every star has planets, and many of these planets might be habitable. Rocky planets like Earth and Mars are even more common in our galaxy than gas giants like Saturn and Jupiter. Also, we already know that our galaxy is very rich in water. There's water in interstellar clouds where stars and planets form, in the debris disks around other stars, in comets, just everywhere. What's really hard though is finding life itself. Ideally, to finally find it, we need to land on every single planet out there and literally check under each rock. But thanks to the newest research, we can at least narrow down the search to potentially habitable worlds. The James Webb Space Telescope, a super powerful telescope that was launched into space in 2021, is onto this. It checks the atmospheres of nearby super-Earths, rocky planets that are a bit bigger than Earth. It searches for life-related gases, chemicals that can only be produced by living things. And they already found some clues. For example, they detected signs of such a chemical on a planet called K2-18b. This planet is 120 light-years away, which is pretty close on a space scale. This planet is in the Goldilocks zone, which means a zone around the star where the temperatures are just right for liquid water to exist. It orbits a red dwarf star, the smallest type of star there is. Such stars are a bit fainter than our Sun. It will take about a year to check if these hints of life are real. If so, it would mean that life is much more common than we previously thought. But even if it's not, there are 10 more Goldilocks planets on their list to study. The James Webb Space Telescope is a very cool tool, but it has limits. It can't detect small Earth-like planets due to their size. To fix this, NASA plans to launch another tool, the Wide Field Infrared Survey Telescope. This one will be even better at spotting such planets and life-related chemicals. And also, we have the SETI project. SETI stands for Search for Extraterrestrial Intelligence. This project has been on a hunt for extraterrestrial creatures since the 1980s. They also believe that we'll find signs of life within the next 10 years. Not so long ago, they started a super big and cool project. It's called COSMIC, and it uses an array of radio telescopes in New Mexico. You might have seen those in the movie Contact. COSMIC allows scientists to listen to hundreds of thousands and potentially millions of star systems at the same time. If there are any interesting signals, scientists can check them right away, instead of waiting for weeks or even months. The signals themselves are often very sudden and short, but COSMIC can detect even the shortest ones that last nanoseconds. COSMIC can also help with other research, like studying mysterious and unexplained fast radio bursts, or even dark matter. This is the biggest and most powerful tool for searching for extraterrestrial life we've ever created. But it's not enough to just listen. Why don't we reach out ourselves? NASA has sent some signals into deep space. In 2002, their Deep Space Network sent a signal to the Pioneer 10 satellite. But there was an obstacle in the path: a white dwarf star 27 light-years away from Earth. If there's a planet around this star, perhaps the signal reached them too. If there are any intelligent species there, we could receive a reply by 2029. The DSN keeps sending powerful transmissions into space. These signals will bump into 222 stars within the next 3 centuries. Maybe someday we'll receive a reply from somewhere far away. But why haven't we received a response yet? There are about 200 billion galaxies in the universe, each with around 100 billion stars. If just 1% of those stars had one planet, that's still 200 quintillion possible planets. And we can narrow it down even further. If the chance of them having life is 1 in a trillion, that would still leave us a few 100,000 planets. So, where is everyone? This is a famous question known as the Fermi paradox. The first possibility isn't that terrifying. It's possible that the universe is full of life, but this life isn't intelligent in our traditional sense. Some planets might have microbes, birds, or space dinosaurs. This is called the Great Filter Theory. It suggests that there are certain filters that life has to overcome in order to become intelligent, and maybe other species just haven't overcome them yet. Think about it. Life on Earth started in the ocean, then crawled onto land, diversified into many forms, went extinct in massive events 5 times, evolved again, and eventually led to humans. We built societies, developed healthcare, and only then started searching for another life. There's another idea called the Gaian bottleneck hypothesis, which suggests basically the same thing. While it might not be too hard for basic life to start, it's incredibly tough for that life to survive and thrive over long periods. Venus might have had oceans and Earth-like conditions too, but something went wrong. Its oceans boiled away because of a runaway greenhouse effect. Now it's sterile. Mars also had liquid water on its surface once, and both the Moon and Mercury had thick atmospheres for a short time. Meanwhile, Earth has had liquid water on its surface for almost its entire existence. It's super rare and remarkable for a planet to hold temperatures from 32 to 212 degrees Fahrenheit for millions of years. So, maybe it's a mistake to look for intelligent life, especially the one that uses the same technology as we do. It evolved under completely different conditions after all. That's also where the so-called Drake equation comes in. It's a formula that gives us a chance to calculate the potential of life becoming intelligent on a planet. To calculate the result, we need to know several variables: how many stars there are, how many of them have planets, the chance of these planets having life, and so on. Unfortunately, we don't know these numbers yet, and the result might be insignificant. But let's assume that there is at least one other intelligent species. Why haven't we met yet? There might be many reasons. Maybe they don't think we're interesting enough, or maybe the problem is with us. Perhaps we keep missing their signals, or maybe we missed the entire species itself. The universe is insanely huge and ancient. It's over 14 billion years old. If we compress Earth's entire evolutionary history into a 24-hour day, life starts at 4 a.m. Dinosaurs go extinct at 11:40 p.m. Human-like creatures appear 2 minutes before midnight. In this analogy, humans have existed for just 77 seconds, and our technology capable of detecting extraterrestrial life is even newer, less than a second. With such vast distances and time spans, the chances of us existing at the same time as other civilizations are slim. If their civilization lasted only a few millennia, we could easily miss them entirely. But that doesn't mean we should give up our search. Scientists were worried that Earth's radio signals had dimmed over time. But a recent study showed that it's actually the opposite. The numbers of our satellites keeps growing, and this makes our planet more detectable. By the end of the decade, we could have 100,000 satellites, making Earth incredibly bright in the radio spectrum. If there is an advanced civilization out there, They will easily spot us even from very far distances. Astronomers are super optimistic about it. There's a high chance they'll find extraterrestrial creatures while you and I are still around.
You take off from Earth and park your spacecraft somewhere near the moon. You're now almost 240,000 miles away from your home planet. That's almost 100 widths of the United States. Now you take out a giant hammer and an enormous chisel using the robotic arms of your spaceship. You place the chisel at the Earth's North Pole and strike its head with the hammer. Earth splits open like an eggshell, and you see it, another planet. It's Theia, and it's hiding inside our planet like a yolk in an egg. You'd need to go back in time 4.5 billion years to find out how it got there. This beautiful nebula will soon become our solar system. Colored dust and various space debris are slowly coming closer toward the common center. Soon this jigsaw puzzle of debris becomes too heavy and dense. The temperature inside the giant is rising. Soon it gets so high that it triggers a nuclear chain reaction. Another second and bam! There's an explosion so powerful that the shock waves travel far into dark space. And the blinding flash from this blast can be seen from the other side of the Milky Way galaxy. When the dust clears a little, you can see that a bright light is still shining at the very center of the explosion. This newborn star is the Sun. It weighs as much as 333,000 Earths. If the Sun was a bucket, you'd need 1.3 million Earth-sized planets to fill it. You're interested in a small object over there, 93 million miles away from the Sun. This pile of rocks and hot lava is Earth. Right now, the planet is busy forming its core, while the oceans of lava are gradually cooling down. But a few tens of million years after the Sun's birth, you notice a strange object hurtling toward Earth. It's Theia. This small planet was born at about the same time as Earth, and now it's following a crazy spiral trajectory at enormous speed. Scientists believe Theia was kind of a ball Jupiter and Venus played with. Venus was pulling Theia in one direction, then Big Brother Jupiter pulled it back. But the Sun makes up 99.8% of the mass of the entire solar system. That's why the star sets its own rules. It makes Theia move in almost the same orbit as Earth. So they inevitably come closer and closer to each other until they become next-door neighbors. We see that Theia is the size of Mars and as wide as the Atlantic Ocean from New York to Portugal. A collision can't be avoided. Theia is traveling toward Earth at nearly 9,000 miles per hour. That's 11 times faster than the speed of sound. If the smaller planet crashes into Earth at a particular angle, Earth will most likely be torn apart, as well as Theia itself. The collision will cause a huge blast, visible on other planets even on a bright day. Nothing will be left but some burning dust and debris. Even if Theia touches Earth only lightly, it'll still knock out a chunk of our planet the size of Australia. But the collision with Theia happens at a perfect 45-degree angle. It strikes the Earth at tremendous speed. The explosion literally vaporizes huge amounts of rock, and the shock wave sends the remaining debris into Earth's orbit. A huge crater is formed at the impact site. Soon it gets filled with boiling lava. The remnants of Theia and the ejected fragments of Earth begin to orbit our planet. According to one version, these fragments form two moons. At first, they travel together, but one day they get too close to each other and collide, forming one large space body. The other theory claims that all the shards start being pulled by the remnants of Theia. Sometime later, they form the moon as we now know it. At that point in the past, though, it's just red-hot rock and lava. The collision at this angle slightly tilts our planet and accelerates its rotation. It's because of Theia that we have different seasons and 24 hours in a day. Earth has lithospheric plates. These are enormous solid pieces that make up the crust of our planet. After the collision with Theia, they start to break and crack. It causes carbon, a primary component of all known life on Earth, to start moving all over our planet. So, Earth gets some kind of metabolism. After a few 100 million years, the first living creatures start to appear on our planet. Over nearly 4 billion years, simple single-celled organisms have been evolving into the life you see today. According to scientists, such a collision is a very rare event. The probability that somewhere out there, there's a planet like ours that has survived the same catastrophe is extremely small. This may be the reason why we are yet to find traces of other civilizations out there in space. Meanwhile, the remains of Theia are still here on Earth. Of course, it doesn't look like an entire planet stuck inside our own. Most of the fragments have melted and blended into the Earth's crust. If you take the top layer off our planet, you'll see two huge lava blobs the size of entire continents. They're right below Africa and the Pacific Ocean. Presumably, these are the remains of Theia. They didn't mix with Earth's mantle because of different densities. It's like mixing water and oil in a glass. The oil will always float up over the water and create an even layer on top of it. But if you raise those lava patches up to the surface, they'd be 100 times higher than Mount Everest. Other remains of Theia might be on the moon. The Apollo space missions brought back many soil samples for analysis. Scientists have concluded that the moon is very similar to Earth in structure. People could drill deep down and take samples there. Then they'd analyze the blobs from Earth. If their structure matched, it'd be 100% proof that Theia did hit Earth 4.5 billion years ago. And that's how we got the moon. But for the time being, Theia remains somewhat mysterious. Scientists are still not sure that the planet actually existed. The whole idea perfectly fits the model of the moon's creation. But in fact, this incredible collision may have never happened.
Hop on the bright side of life together with our brand new tees, hoodies, and more. Click the link to pick your choice.
Now you travel 41 light-years away from Earth to the planet 55 Cancri E. It's about twice the size of Earth and 8 times heavier. You take out your giant hammer again and use it to hit the chisel. The planet cracks, and you see it's a giant diamond. The temperature on this planet is tens of times higher than that of Earth, and its soil is rich in carbon. The heat puts a lot of pressure on this carbon. Its structure changes. First, it turns into graphite. Some more pressure, and graphite turns into diamond. On Earth, diamonds form at depths below 60 miles, where the pressure is 50,000 times greater than on the surface. The temperatures there rise over 1,000 degrees, which is as hot as fire. Diamonds are ejected closer to the surface in volcanic eruptions. Still, people have to dig mines 1,500 feet deep to find these beautiful gems. The Golden Jubilee diamond is the biggest cut and faceted diamond on Earth. It weighs as much as a chocolate bar and is the size of a hamster. Its price is about $12 million. Now imagine a diamond the size of an entire planet. You decide to fly back to the solar system. Your destination is Jupiter's moon, Europa. It's as wide as the distance between Seattle and Houston, and its mass is less than 1% the mass of Earth. Its surface is enclosed in an icy crust. It's about 19 miles thick. But what if you crack this crust with your giant hammer? Wow, Europa is completely covered in water. It's freezing here, 3 times colder than at the North Pole on Earth. The water turns into ice almost instantly, but the ocean beneath the surface is still liquid. Europa interacts with Jupiter gravitationally, just like the moon with Earth. This creates tidal forces and heats Europa's core. The core melts the ice around it. The result is a huge ocean, 2 to 3 times larger than all of Earth's oceans combined. Scientists believe that water is the basis of life. It may mean that life may exist on Europa. There could be thermal springs, just like at the bottom of our oceans. The water there is probably much warmer. And even though the pressure and temperature in such places are likely to be extreme, simple bacteria may live there. Europa is almost the same age as Earth. This means there's been enough time for living organisms to appear and evolve. Who knows? Maybe some advanced civilization is already blooming under this crust of ice. They may be building big cities and dreaming of conquering space right now. But the only thing people can do at the moment is send a probe to Europa and find out if life is possible there.
The search for ET is on. It's most definitely on. With the successful launch of the James Webb Telescope, the search for Earth-like planets has become a riveting topic of worldwide attention. Apart from the James Webb Telescope, other tools are being used to find good Earth-like candidates. The TESS satellite and the Kepler telescope are at the forefront of searching for other Earths. After we first clear the air of a few pesky philosophical questions, we'll take a close look at these two searches and what the James Webb Telescope hopes to find. So, why are we searching for Earth-like planets? Well, because we can. Incredible advances in Earthbound telescope technology have enabled ultra-precise observations of starlight, which led to the earliest discovery of exoplanets. As planets go around stars, there's a gravitational interaction between the planet and the star. They pull each other. The planet's pull upon the star will cause the starlight to wobble back and forth ever so slightly as the planet or planets orbit the star. This has always been the case, but the wobble of the starlight was never able to be detected, because starlight always twinkles. Twinkle, twinkle, etc. Adaptive optics inside telescopes is the technological breakthrough that first enabled astronomers to find exoplanets, by taking the twinkle out of starlight. Mechanical springs on the underside of telescope mirrors bend the mirrors ever so slightly to neutralize the distortion, the twinkle, caused by starlight passing through Earth's atmosphere. Without the glimmer of starlight, the slight wobble caused by planets pulling gravitationally on the stars is observable. The bigger the wobble, the more planets. It's called the astrometric method of exoplanet detection. Isn't that a mouthful? Whole star systems and literally thousands of exoplanets were inferred to exist around nearby stars by analyzing the wobbly patterns of starlight. But the planets themselves could not be seen. Suddenly, our solar system was not unique anymore. Astronomers got giddy over the inescapable conclusion that probably every star had planets. It became impossible not to ask the poignant question, is the Earth unique, or are there other Earths? What's the big deal about finding Earth-like planets anyways? Well, considering all the financial resources the developed countries are spending on finding Earth-like planets, it can be said without a doubt that it's definitely a big deal. Including the launched James Webb Telescope, which cost $10 billion, the Kepler Space Telescope, which cost $550 million, and the TESS satellite, which cost $200 million. The investment in finding Earth-like planets is certainly eyebrow-raising. Now, if you keep in mind that these costs are just for the hardware, and to get a sketch of the full magnitude of the search, you must also include the salaries of a team of data miners, PhD analysts, and postgrads all across the globe in universities, national space agencies, and private institutions. We will conclude that finding another Earth is truly an immense undertaking. Now, suppose we find one. Then Earth is not alone anymore. It's not that we can actually go to any of these planets anytime soon. Interstellar travel requires some breakthroughs in physics and technology, and, well, we aren't there yet. But knowing that there are planets out there in the Milky Way that are like Earth in all the essential respects, like liquid water, oxygen, and habitability, will make space less foreboding, more welcoming, more exciting to study and explore. It may also give us some more pride in our home planet and make us all better Earthlings. The triple mission looking for other Earths, the Kepler telescope, the TESS satellite, and the James Webb telescope use distinct approaches to find exoplanets. And the synonym TESS tells us what that method is. The T stands for transiting, and that's the key to the whole exoplanet search. E stands for, you guessed it, exoplanets, the target of the excellent investigation of another Earth. S stands for survey, because TESS looks at hundreds of thousands of nearby stars. And S stands for satellite, because TESS is orbiting Earth, unlike the James Webb Space Telescope, which will orbit the Sun. When a planet passes in front of a star, that is called a transit. The planet will block some of the light coming from the star. This decrease or dimming of the star can be measured. The dimming of starlight tells lots of things about the planet. By knowing how bright the star is and how much the star's light was dimmed by a transition in front of the star, we can tell how giant the planet is or how close it is. But we won't know which. Is it big or is it close? Until the planet's orbit is also timed. It means our TESS satellite must take long-duration videos of the stars. Ooh, video of the stars. Hollywood should like that. The TESS satellite doesn't have a telescope. It uses 4 CCD cameras to stream live long-duration videos of as many stars as possible, hundreds of thousands of stars. Why so many? Well, because for a transit of a planet to be observed, it must pass directly between the test satellite's cameras and the star. If the planet is not on the exact line of sight angle between the star and TESS's cameras, it cannot be seen because it will not cut off any starlights. Planetary transits are rare. For example, Venus passes across Earth's view of the Sun only every couple hundred years, yet TESS's cameras are seeing many planetary transits among the hundreds of thousands of stars it takes streaming long-duration videos of, and you know what that means. It means there must be hundreds or thousands of times more planets than are observed by the transiting method. It is, therefore, an inescapable conclusion that every star has planets. Planets are everywhere. And now, the James Webb Space Telescope, with its giant 21-foot 4-inch-wide mirror, is entering the search. It is a technological marvel, a wonder of the modern world, a miracle of advanced engineering. Anticipation is reaching a fever pitch. But with the heightened anticipation comes an almost equal amount of trepidation. And some things can still go wrong before the James Webb Space Telescope returns its first pictures. After the Hubble Space Telescope, for example, was launched in 1990, a repair mission had to be launched in 1993. The mirror on the Hubble was not very well inspected, and its pictures were very blurry. Astronauts had to go up and execute a spectacular spacewalk to fix the mirror. After the fix, the pictures Hubble sent back were more precise than it was ever designed for. This is how an improved model appeared. That cannot happen with the James Webb Telescope. The Hubble orbits the Earth and is accessible to astronauts. The James Webb Space Telescope orbits the Sun and is well beyond the Moon, out of the reach of astronauts, because there is no spacecraft equipped to carry them there. It cannot be manually fixed if something goes wrong. Adding to the challenges, the James Webb Space Telescope has only one onboard camera to inspect any damage it may suffer or mechanical malfunctions that might develop in the harsh environment of interplanetary space. Any remote fixes will need to be done blind from Earth. The James Webb Space Telescope is now fully deployed. The 18 mirror segments will need to be aligned to produce a single image. This critically important process will take several months to complete once the telescope is fully deployed. 70 of the first 286 observation assignments of the telescope target exoplanets. Using data from previous exoplanet searches, it will not have to waste time searching for exoplanets. Their locations and orbits are already known. The James Webb Telescope will go right after them. The James Webb Space Telescope is not an optical telescope in the same sense as the Hubble Space Telescope or any ordinary telescope that sees visible light. It sees infrared light. The pictures of planets are expected to be bright dots, somewhat fuzzy if they have atmospheres. The spectra of the planets will yield the most information about the exoplanet. Any gases around an exoplanet will absorb some starlight as the starlight passes through the planet's atmospheres. Suppose there is methane in the planet's atmosphere, oxygen, or carbon dioxide, the gases that most indicate life. In that case, the James Webb Telescope will be able to pick them up by spectroscopic analysis. An entire portrait of the exoplanet can be formed from the infrared information, its temperature ranges, atmospheric content, the likelihood of liquid water, and even the probability of life. And that's a big deal. The James Webb Space Telescope has other missions to perform too. It's assigned to examine star formation and planet formation in nebula in the Milky Way. Understanding how solar systems form is part of the search for another Earth. By detecting infrared light, the James Webb Space Telescope will peer to the farthest away galaxies whose visible light gets blocked by dust and gas. These distant galaxies were formed shortly after the Big Bang. Galaxy formation is an essential mission for the James Webb Telescope. These most distant galaxies are accelerating away so fast that the light they emit is stretched below the frequency of the visible spectrum, into the infrared. The Great Telescope can see these previously invisible galaxies. We hope to learn about the mysterious dark energy that is causing the universe to expand at an ever-increasing velocity. Hope is high that the James Webb Space Telescope will significantly expand our knowledge of this amazing universe we all live in.
Scientists think there might be a huge onion chilling somewhere out there in space. Not an actual one, but it's something even crazier. These are stars stacked inside each other, layer upon layer. These fascinating objects, called gravastars, could even be cousins of black holes. But most importantly, they might hold the key to understanding some of the most mysterious puzzles in the universe, dark energy, and even other dimensions. Let's start with gravity. Over a century ago, Albert Einstein helped us understand how gravity works. Turns out, it's not just something that pulls things on Earth and makes apples fall on Newton's head. It's much wilder. It's about warping the very fabric of existence itself. Let's say you toss a heavy ball like a bowling ball onto the middle of your bed. What happens to the sheets? They dip, don't they? They stretch and sag around the ball. Now, if you roll a smaller ball like a marble across the bed, it doesn't move in a straight line anymore. Instead, it starts circling the heavy ball, rolling closer and closer as if the heavy ball is pulling it in. That's gravity. But instead of bed sheets, we're talking about the fabric of space and time itself, or space-time for short. Heavy objects like planets and stars make dents in space-time, and moons, planets, or even light move along these dents. Gravity is the curve that tells them where to go. In that case, you can guess that black holes are like the ultimate heavy balls. The heaviest, in fact. The gravity is so strong, it shrinks them, making them smaller and smaller. So tiny, they could fit in the palm of your hand, but with the mass of several suns. Some of them are like holding over 40 billion solar masses in your palm. It's ridiculous, but they basically create a bottomless pit in space-time with insane gravity. This area around them, called the event horizon, is the most horrifying thing ever. It's a point of no return. Once something gets there, it can never escape being eaten. When something falls past the event horizon, it can't climb back out, not even light. Which is why they seem like, well, black holes. But gravastars, they're something much weirder. Just like black holes, they're probably very compact. But instead of being tiny pits of endless gravity, they might have something wild at their core: dark energy. This is one of the universe's biggest mysteries. Dark energy, this invisible, mysterious something that seems to be pushing the universe apart faster and faster. It's like a polar opposite of gravity. While gravity tries to pull things together to slow down the expansion of the universe, dark energy is trying its hardest to make our world even bigger. Luckily, dark energy has been winning so far. Otherwise, we'd all be in some deep pit. But if we can explain the gravity with balls, then what exactly is dark energy? A force, an energy field. Something else? We have no idea. Scientists have seen its effects. They know that it's incredibly spread out everywhere, but they can't tell you what that thing even is. But if it's trapped inside of gravastars, maybe we'll finally discover the truth. This name stands for gravitational condensate stars. Gravastars were dreamed up by two physics professors, Powell Mazur and Emil Mottola, in 2006. They tried to think, what else besides black holes could happen when a massive star collapses on itself? That's how they created this alternative. Think of it this way. Gravity pulls everything inward, making super heavy objects like stars shrink in size. The more the star shrinks, the denser it gets, and its gravity grows stronger. After some point, it can cross a critical threshold and become a black hole. But what if there was dark energy inside to counteract this? At the core of a gravistar, there could be a region filled with false vacuum or dark energy. This energy would push outward, fighting the gravity. It's like the unstoppable force meets an immovable object. Thanks to this, the star core doesn't collapse into a black hole. Sounds wacky. We don't know what dark energy even is, so how can it fill up anything? But luckily, even if scientists can't fully explain dark energy, they still have strong mathematical models to check how it works in our universe. So, they decided to test this theory. Here's where things get even weirder. The new theory says that gravastars might not be simple lone objects. Instead, they could be stacked one inside another. Each one is like a layer with its own dark energy bubble inside, surrounded by a thin skin of matter. The outermost shell would hold a smaller gravastar inside it, and that one could hold an even smaller one, and so on. It's like a series of balloons, one inside the other. The air pressure in each one of them is stable, evenly spread out. Thanks to that, none of them deflate. They coexist without one popping or collapsing the others. In the case of gravastars, the air is dark energy, and the rubber is the shell of matter surrounding it. It sounds crazy, but it actually makes this whole idea more realistic. A single gravastar might have a very thin shell of matter, but the thicker they are, the more likely it is to exist in a stable way. And finally, the coolest part about them is that they could explain one of the biggest mysteries of our world: how universes are born. When a star collapses into a gravastar, the matter could theoretically implode through the center and create a new dimension. This would connect these objects to the Big Bang itself. Some scientists even speculate that dark energy could be the energy exchanged between our universe and a child universe that's created from a gravastar. Of course, these are all just speculations for now. But where are all those gravastars? And how do we test this? Well, physicists aren't sure either. They're more of a what-if thing than an actual object that they discovered. Those two professors just tried to imagine what would happen if gravity and dark energy worked together like this. For now, the LIGO, a big observatory which detects ripples in spacetime, hasn't found clear evidence of gravastars. Another problem is that gravastars would only be stable in specific cases. For example, if they spin too fast or their shell will be too thick, they might start to wobble or break apart eventually, though it could actually take billions of years. Plus, even if we don't see them right now, remember that this is exactly what happened to the black holes themselves. When Einstein published his groundbreaking theory of general relativity, another scientist, Carl Schwarzschild, took his equations and found a solution to them. And that's when he realized, if gravity becomes incredibly strong, the light wouldn't be able to escape, and this could create a sort of hole in space. Einstein even thought that this sounds too weird to be true. It took many years for us to confirm black holes' existence, and we finally took a photo of one just a couple of years ago. You might remember that blurry picture that blew up online? It was Sagittarius A star, an incredible supermassive black hole in the center of our galaxy, Milky Way. So that's why scientists approach gravastars so seriously. And since all the math checked out, which means that these objects are actually possible in real life. Now, we just need to see if they're somewhere out there. What's interesting is that they'd probably look like regular black holes. They could emit high-energy radiation as they consume matter. They might even produce something called Hawking radiation, a type of energy that escapes from black holes. In other words, it would be nearly impossible to tell the difference. But gravastars have a small trick up their sleeve. If their shell is transparent to light, they might bend light in a slightly different way than black holes do. So maybe if they check the way light is bent around the mysterious object, they could spot the difference. And even if it turns out that gravastars don't exist in our reality, they're still valuable to science. They still taught us more about gravity, black holes, and the limits of relativity.
Tiny critters to colossal creatures, all animals are trying to escape from a wall of fire moving in their direction. The temperature is rising, and everything around starts catching fire. Soon, lots of animals and plants on Earth will cease to exist. This is the aftermath of a giant asteroid crashing into our planet. But what if dinosaurs had had critical thinking skills? They could have guessed what was going to happen, because this asteroid was visible a year before the impact. 1 year before the impact. With no city lights, all bright spots in the sky are stars. Some of them are planets reflecting the light coming from the sun, like Mars. But one of these dots is the asteroid. Later, it's going to be known as Chicxulub Impactor. It got this name because of the region of modern-day Mexico where it fell. Anyway, at this point, the asteroid looks like a star. It has the same brightness as Neptune. You could even have photographed it with a high-quality camera. If only dinosaurs had thumbs. The impactor is now passing through Jupiter's orbit. From this distance, Earth looks like a pale blue dot. 1 month before impact. The asteroid has become much brighter. It's now the most brilliant spot in the night sky after the Moon. The asteroid crosses the orbit of Mars. Its tail, consisting of dust and gas, is getting longer and longer. It's now as long as 2 times the distance from Earth to the Moon. 1 week before the impact. The intruder's tail is now 5 times the distance from the Earth to the Moon, but the dinosaurs can't appreciate its beauty. To them, it's just another bright dot in the night sky. If this asteroid were flying toward Earth right now, scientists could pinpoint the exact location of its impact within a mile. Then we would evacuate people from the impact area and avoid a major catastrophe. 1 day before the impact. The Chicxulub Impactor now holds first place among the brightest objects in the sky. The light surrounding it, called the halo, seems even bigger than the Moon itself. The asteroid is now passing through the Moon's orbit. It looks like a bright spot that leaves an ashy trail behind it. 1 hour before the impact. The light from the Chicxulub Impactor is brighter than the full Moon, and its movement can be seen with the unaided eye. Nights on Earth aren't dark anymore. Only now, dinosaurs begin to feel anxious. All animals on Earth start to seek shelter. 10 minutes before the impact. The asteroid is now passing through Earth's orbit. Thousands of small fragments from its tail begin to fall on the planet. It looks like a meteor shower. So far, these fragments are too small. They all burn up in the atmosphere before reaching the surface of the planet. The asteroid is approaching South America. If someone was looking at it from Europe, it looked like a sunset. The bright dot of the Chicxulub Impactor is falling behind the horizon. 2 minutes before the impact. Dinosaurs can now easily see the asteroid's shape. If they knew how to do it, they could even estimate its size. It's a bit more than 6 miles across, which means it's almost the size of Manhattan Island, and the giant's weight is 15 plus 15 zeros pounds. It's flying toward the Yucatan Peninsula at a mind-boggling 7.5 miles per second. At that speed, you could get from New York to Los Angeles in around 10 minutes, but you'd kind of burn up on the way. 10 seconds before the impact. The Chicxulub Impactor is now approaching the ground. A few more feet and bam! The night sky suddenly turns white. The flash is so bright that the sun isn't visible at this point. The asteroid's entry causes a powerful blast that can be heard on the other side of the world. The huge asteroid begins to burn because of friction with the air. It heats up and splits into many pieces. These pieces shower on Earth. After a few seconds, the largest part of the meteorite hits the ground. Its mass and speed provide the Chicxulub Impactor with an enormous amount of energy. In the next moment, a super powerful explosion shakes the ground. The blast wave from the meteorite begins to spread out from the impact site. It rips out huge chunks of soil and trees and then pushes them to the ground like dominoes. The temperature of the blast wave is so high that everything around the impact site catches fire. The energy released during the collision also penetrates deep into the planet. This causes the strongest earthquakes in our planet's history. They, in turn, generate tsunami waves as high as the Empire State Building. 5 minutes after the impact. The meteorite leaves behind a huge crater. It's as wide as Lake Huron and deep enough to fit inside 2.5 Mount Everests. Dinosaurs are running around in panic. They try to evacuate toward North America, but most of them don't make it through unfamiliar swampy territories. Another danger is the ongoing meteor shower. Hundreds of tons of ash and debris rise into the air. Heated up by high temperatures, they fall to Earth in the form of liquid lava. Ash and smoke fill the atmosphere and block the sun's rays. Earth plunges into darkness. For several more weeks, our planet will be totally dark. Acid rains will fall on its surface non-stop. There was a lot of sulfur in underground deposits on the Yucatan Peninsula. The energy of the explosion evaporated all this sulfur. Now it's cooling in the air, gathering in clouds, and dripping to the ground. Most animals survive the impact, but the mass extinction continues for many more months. The collision has plunged Earth into darkness, and this has wiped out most of the plants that fed on sunlight. The plant-eating dinosaurs have lost their main food source and begin to disappear. But plant-eating dinosaurs are the main diet of meat-eaters, and now dinosaurs like T-Rex have nothing to eat. Soon they go extinct too. In other words, it wasn't a meteorite that wiped out dinosaurs, but hunger and climate change. Meteorites of this size fall once every 100 million years. It means that such an event might happen again. Will humans manage to survive this disaster? These days, we can look out far into space, and the appearance of an asteroid the size of the Chicxulub impactor won't be a surprise to astronomers. In general, asteroids that are more than 460 feet across are considered potentially dangerous. Anyway, if we know about the approaching space body, we'll be able to build shelters filled with food and water supplies. Once the asteroid is close enough, we can wait for the impact and its consequences inside. But when people come back to the surface, they'll see cities and towns torn down. Our planet will look like a lifeless desert. That's why we need another alternative, which is to prevent the impact. Here, we have many options depending on the size and material of the asteroid. According to NASA, the most effective way is a kinetic ram. We'll need to send a fairly large and heavy object, such as a spaceship, into space. When it approaches the asteroid, scientists will choose the perfect trajectory, and the ship will crash into the space body. A powerful collision will change the asteroid's course, making it fly past Earth. The further the space body is from our planet, the easier it'll be to send it away. Another option is a controlled explosion on the surface of the asteroid. Newton's first law of motion will help us here. It says if a body is moving at a constant speed in a straight line, it will keep moving that way unless it is acted upon by a force. So, if we make a big enough explosion or force, the asteroid will shift its trajectory. How much it moves depends on the amount of force applied to it. We can also blast the asteroid right from inside. In this case, there will be no need to change its trajectory. Instead, we'll try to turn one huge hunk of rock into a bunch of smaller fragments. They will burn up in the atmosphere and do no harm to our planet. Another way is a gravity tug. Every heavy object has its own gravitational force and gravitational field. Our goal will be to send a spacecraft to the asteroid and make it fly close to the intruder. The asteroid will attract the spaceship, but its engines will resist. As a result, the ship will slowly but surely pull the asteroid toward itself. This method will take much longer, but gradually, the trajectory of the asteroid will change and it won't crash into Earth, hopefully. We can also use solar power. We can build a spaceship with a system of giant magnifying lenses. Then we'll send that station closer to the Sun. When we spot an asteroid, we'll point the lens in its direction and focus the beam on the space body. The heat from the Sun will cause the asteroid's material to evaporate. Eventually, this will make the intruder change its trajectory.
It was a warm morning in Siberia, June 30th, 1908. Suddenly, a bright flash illuminated the sky. It was an event no one could explain for decades. The Tunguska explosion, one of the most mysterious disasters to have ever occurred on Earth. It could have been an asteroid crash, like the one that destroyed dinosaurs millions of years ago. But for one creepy fact, there was no impact crater. The event itself happened in the vast forests of northern Siberia, over the Podkamennaya Tunguska River. The blast was so insanely powerful that it leveled about 80 million trees across a massive area of 830 square miles. What phenomenon could have had such an immense force? No one could understand it. Thousands of animals lost their lives and the ground lay scorched. Witnesses saw glowing skies and something they described as a fireball, a bluish light brighter than the sun that had streaked across the sky. Seconds later, there was a flash and a sound like artillery fire. The shockwave shattered windows hundreds of miles away. People felt the blast's force, getting knocked off their feet from afar. For years, scientists puzzled over what exactly had happened. As I've already mentioned, weirdly, the area had no impact crater. But the damage and eyewitness reports left no doubt that something immense and horrifying had occurred. This bizarre lack of evidence resulted in wild theories. Some people suggested it was an alien spacecraft that had crashed in the region. Others speculated it might have been a mini black hole or antimatter particle. There was also an idea that about 10 million tons of natural gas had leaked from deep in Earth's crust. This gas rose into the atmosphere and drifted along like a giant invisible wick. Eventually, there was a spark, maybe lightning, which set it on fire. The flames traveled down the wick of gas back to its source on the ground, causing a huge explosion. But this idea didn't get very popular. Which theory was true? Scientists couldn't agree on one and were in doubt. To add to the mystery, the impact area was incredibly difficult to reach. It took almost 2 decades before scientists could investigate that remote site. In 1927, scientist Leonid Kulik brought an expedition there. They did their best to investigate the region and find the long-awaited answers. But they found nothing. No meteorite fragments, no crater, just millions of fallen trees and slowly disappearing signs of total devastation. The mystery began to clear when a similar event occurred over a century later. On February 15, 2013, the Chelyabinsk meteor exploded in an airburst over Chelyabinsk, around 1,500 miles west of Tunguska. This time, many people witnessed and recorded the event on video, which gave scientists vital clues. New computer models helped scientists reconstruct the size, speed, and impact of the Chelyabinsk meteor. It was likely a large asteroid about the size of a 5-story building, exploding around 15 miles above ground. The blast shattered 1 million windows and hurt over 1,000 people. Fortunately, it wasn't powerful enough to cause damage on the same scale as Tunguska. Now imagine a meteoroid racing into Earth's atmosphere, transforming into a blazing meteor. It's traveling so fast that the air in front of it compresses and heats up, setting it on fire. But it's so large that it doesn't just burn up. All of a sudden, it explodes. When that happens, the blast releases so much energy that a powerful shockwave spreads out. Since this explosion happens in the air, it leaves no impact crater. Back in the early 1900s, with limited technology and the remote location, scientists were left with a puzzle. Only much later did they eventually conclude it had been an airburst, where an object explodes high in the atmosphere, never striking the ground but releasing enough energy to devastate the area. Most likely, it was a giant asteroid about the size of a 25-story building. It could have been moving at around 33,500 miles per hour and exploding about 3 to 6 miles above Earth's surface with enormous, incomparable force.
Seen a good horror movie lately? If you're a fan of those, then you can appreciate a good plot. But what if I told you that Mother Nature is the best scriptwriter ever? Ancient disasters were scarier than any horror movie today. From tsunamis to volcanic eruptions, you'll be shocked by the scale of these events. One natural disaster you definitely don't want to experience is a tsunami. Those gigantic walls of water sweep across the coast and take out everything in their way. And it's nothing new for our planet. Scientists were able to piece together a timeline based on evidence that major tsunamis left. In northern Chile, a large boulder sits high above the Pacific Ocean. Behind it, a desert as far as the eye can see. This 44-ton stone obviously doesn't belong here. It's the result of an ancient tsunami. Waves as high as a 6-story building carried boulders like pebbles. Researchers estimate this happened in 1420. But how can they possibly know this? In the 15th century, there were no written records in the region. Time for some detective work. Archaeologists discovered that around the same time, there was a tsunami in Japan, on the other side of the Pacific Ocean. The ground shook off the coast of Chile. That's how the tsunami was created. Then the wave traveled nearly 2/5 of the Earth's circumference. That's one tireless tsunami. But this wasn't a one-time event. Evidence suggests that a similar event happened 3,800 years ago. Ancient people abandoned their coastal villages around this time. They were moving inland. How did they know it was time to go? There's evidence of erosion due to strong currents, telltale signs of an ancient tsunami. As you know from school textbooks, Oxygen is 21% of the air we breathe, but it wasn't always a part of Earth's atmosphere. Oxygen was missing during the first half of our planet's lifespan. Carbon dioxide and methane were the name of the game back then. CO2 is what makes our drinks fizz, but isn't the other gas dangerous? Yes, because you can't smell methane, and that's the reason there was no life on Earth billions of years ago. So how did we get from methane to oxygen? In come the cyanobacteria. This group of microbes started to evolve some 2.7 billion years ago. These tiny microbes mastered photosynthesis, converting sunlight into energy. And the byproduct of this process was, you've guessed it, oxygen. Soon it started escaping from water into the atmosphere. There, it reacted with methane, and over time, O2 replaced it completely. Scientists named this process the Great Oxidation Event. But how could it be bad? After all, we're alive thanks to it. All that oxygen acted as a poison for anaerobic organisms. And no, these are not life forms that didn't do aerobics or Pilates. The term simply means that these microorganisms didn't need oxygen to grow. Too much oxygen, and they would be goners. And that's precisely what happened. Scientists spoke of an oxygen overshoot that changed Earth's atmosphere for good. The disappearance of most anaerobic organisms was an early example of an extinction event. They didn't like the atmosphere at the time and decided to step down. But look on the bright side. They made room for oxygen-loving humans to enter the picture. Let's go to Turkey. No, not the seaside resorts that tourists visit in the summer, but the region of Anatolia in the southeast of the country. Göbekli Tepe is the world's oldest known temple site. It dates back to the Neolithic period. Scientists found a stone pillar here that tells a tale of an ancient disaster. They presume that the pillar is commemorative. Today, humans still build similar structures to mark an important event or a person. Just one example is the Washington Memorial. It was built in honor of the first American president, George Washington. But the pillar in Turkey doesn't commemorate a happy event. Scientists believe it shows a devastating occurrence, a comet crashing into the Earth. The event must have been destructive. There are also other signs on the monument. These symbols align with the setup of the night sky stars for the year 10,950 BCE. The date astounded the researchers. It matched their earlier research of an ice core sample in Greenland. This showed that a comet fragment hit our planet around the same time. The archaeological site could have easily been an ancient observatory. And whoever worked at it observed a cataclysmic event. The impact must have been so powerful that it changed the Earth's rotational axis. That's the imaginary pole going through our planet from top to bottom. That ancient comet must have packed a punch to knock the blue planet off balance. Have you heard of the city of Tal El Hammam in the valley of the Jordan River? The reason why your answer is probably no is that the city doesn't exist today. It completely disappeared around the year 1650 BCE. It was one of the three major cities in this part of the Middle East. Together, these three cities had a population bigger than Palm Springs today. At the time, Tal El Hammam was a metropolis. It even had high-rises, 5-story buildings constructed using mud bricks. But archaeologists found strange markings on them. The bricks melted as they were exposed to high temperatures. Yes, sound the fire alarm. Some sort of disaster had caused a major fire. Archaeological finds pointed to a suspect for such damage, a rock from space. So, where was the crater? This comet, or an asteroid, never made it to the ground. It was traveling at high speed, so it disintegrated before hitting the ground. Such an event is called an airburst. The largest witnessed meteor airburst happened over Tunguska in the north of Asia in 1908. Scientists estimated that the airburst in Tal El Hammam happened 2.5 miles above the city. This event released a lot of energy. Air temperature quickly rose to 3,600 degrees Fahrenheit. That's hot enough to set clothes and wood on fire in an instant. Mud bricks and tools made from metal start to melt when exposed to such heat. This would explain the evidence scientists unearthed. But there was one more find: salt. The event was so powerful that it distributed salt over the region around the Dead Sea. Any farmer will tell you that salty soil and crops don't go well together. People started moving away from the area because they couldn't grow food. Imagine an island with whitewashed villages surrounded by a sapphire blue sea. Such a place exists in reality. It's the island of Santorini. But the history of this place hides a tale of destruction. The island is of volcanic origin. This means that a violent eruption created it some 3,000 years ago. Now there are two islands. The bigger one is shaped like a horseshoe. When you look at them from above, the two islands look like they form a circle. That's because they were once a single island. It had a large mountain and was round in shape. But then it all changed almost overnight. One of the largest volcanic eruptions in human history tore Santorini apart. The earth trembled, tsunamis formed, and clouds of ash filled the sky. A daunting image. People felt the eruption hundreds of miles away. When it was all over, seawater rushed into the caldera of the former volcano. That's why the water in the lagoon has such a beautiful color. Scientists know so much about Santorini's past because of an unlikely assistant, a tree. The juniper tree, to be exact. People use its aromatic wood for everything from furniture to making pencils. On the Greek island, its rings revealed the tale of the ancient eruption. As a tree grows, it doesn't only go up, it expands sideways as well. Each new layer of bark adds a ring to the trunk. It takes a year for one ring to form. And on Santorini, one ring was unnaturally pale. The scientists did the math and voila, they dated the eruption to 1560 BCE.
Around 66 million years ago, dinosaurs disappeared from the Earth, except for the ones that eventually turned into birds. Suddenly, the Earth went from the age of dinosaurs to the age of mammals. Scientists have special names for these time periods: the Cretaceous and Paleogene. And the event itself is called the KPG, or KT extinction. Picture this dramatic moment in Earth's history. It happened in the blink of an eye. A colossal asteroid as big as Mount Everest and traveling at lightning speed slammed into Earth. It crashed down in what we now call southern Mexico, at a place known as the Chicxulub crater. The impact was gigantic. Everything close to it was instantly vaporized, creating an enormous burst of energy, one of the most powerful in billions of years. Nothing could survive near the crash site. As the fiery aftermath cooled, the Earth's surface went haywire. The ground twisted and trembled, causing unbelievable earthquakes. The continent started to literally bounce. Then, the ocean floor got all stirred up, provoking the gigantic tsunami. Massive waves surged inland around the Gulf of Mexico. The debris that got blasted into the sky started falling back to Earth like a rainstorm. Even if you weren't close to the huge pieces falling in Mexico, you'd still get hit by smaller, super hot bits flying through the air. This heated up the atmosphere so much that forests all over the world burst into flames. The dinosaurs that lived far away from the impact area first felt a little rumble. Suddenly, the sky turned dark and gloomy, as if it was nighttime during the day. The temperatures dropped drastically, and this night during the day lasted for several weeks. And then, a blanket of ash started slowly covering the entire planet. Nasty things like carbon dioxide and bits of the seafloor started floating around in the air. This messed with the temperatures once again, making it swing wildly. The Earth was hot and cold at the same time. Nature was suffering. Forest fires, no sunlight, dangerous gases in the atmosphere. All this caused big problems for plant-eating dinosaurs. They started to vanish, and the meat-eaters were having a feast. But not for long. Soon enough, the whole food chain fell apart. This is when somewhere between 50 and 80% of dinosaurs said their final goodbyes. What's even sadder is that this number only counts the different types of dinosaurs. If we look at the number of individual dinosaur lives lost, it's even higher. Here's an interesting fact. If the asteroid had hit just 30 seconds earlier or later, landing in the Atlantic or Pacific rather than just off the coast of Mexico, we might have had some non-avian dinosaurs still around today. But the way it happened, the asteroid struck with a force equal to 10 billion Hiroshimas. But the only ones who made it were our mammalian ancestors. They were little shrew-like creatures who had super fast energy systems, adaptable diets, or clever hiding spots. These early mammals survived because they were tiny and didn't need much food. We're incredibly lucky that they survived this chaos. They probably didn't even understand what was happening. They just noticed the horrible smell, huge bodies everywhere, acid rain, and volcanoes erupting. So now that we know how terrible this event actually was, let's talk about a big question. Could we, modern humans, survive something like this? Well, it depends. Research from a different asteroid impact about 790,000 years ago suggests we could, but it wouldn't be easy. In that other event, a massive asteroid hit Earth once again. Just like with the Chicxulub asteroid, it sent debris into the atmosphere that covered a tenth of the planet's surface. Scientists found the pieces of that asteroid's impact, glassy rocks called tektites. They analyzed these rocks and discovered a rare mineral called rhyodite. It requires extremely high pressure and temperatures to form. After studying it, scientists assumed that the impact happened in Southeast Asia, probably near Thailand. Strangely, they still haven't found the exact crater. But the main thing is, the asteroid collision did happen, and our ancestors were around during this. It surely got their attention, even though they might not have fully grasped what was happening. The debris from this event would have caused significant climate changes. It's tough to understand how it affected our humans' evolution. All that we know is that we survived it. Currently, there are about 1,200 asteroids on a list of potential asteroid threats, but luckily we're not in immediate danger. These asteroids are smaller than 0.6 miles in diameter. The chance of a massive asteroid like the one that hit Chicxulub between 3 to 9 miles wide striking Earth is incredibly low. Major events like this happen about once every 100 to 200 million years. On top of that, most asteroids are located between Mars and Jupiter and don't pose a threat to Earth. However, there are thousands of smaller asteroids that could potentially hit us. Most of these are small and burn up in the atmosphere, causing no harm. Some larger ones could damage buildings or cities, but wouldn't threaten all life on our blue planet. But what if a comet or a serious asteroid were to collide with Earth today? In that case, first of all, it could alter Earth's orbit. The initial energy released during an impact would cause a scorching blast wave of 570 degrees Fahrenheit. The fire would ignite vast areas of the Earth's surface. Then, it would cause a long-term impact on winter. The smoke from the megafires, along with dust and water vapor, would form a thick layer of clouds in the upper atmosphere. Just like with the dinosaur event, it would reduce sunlight and cause temperatures to drop for decades. Most plant life would die off within weeks. Large trees might survive for decades due to stored sugars and a slow metabolism. Beyond that, not much life would remain, except for microbes and smaller creatures. There are 3 possible strategies for humans to deal with all this mess. The best strategy is to prevent the impact in the first place. Scientists are already searching for asteroids that might cross Earth's path and discussing how to defend against them. One option is to use our biggest weapons to break up the asteroid into smaller pieces. These tiny pieces could miss Earth or burn up in our atmosphere. That would work for asteroids around 0.6 miles wide. However, this won't work for massive Chicxulub-sized asteroids. The amount of energy we'd need to destroy them exceeds our entire current arsenal. But if we notice the asteroid early enough, maybe a series of blasts could change its course and save the day. And, according to the researchers, asteroids larger than 25 miles in size would be nearly impossible to stop with our current technology. Luckily, the chances of something like this hitting Earth are very tiny. But okay, what if we can't prevent the impact? Here comes the second strategy. We'd have to go deep underground and create large bunkers. We know that many burrowing or deep-sea species survived the mass extinction 66 million years ago, so these underground habitants could protect us from the direct impact effects like blasts and fires, as well as an impact winter. We'd have to harness the Earth's natural heat and live inside protective domes. They could be built in stable continental cores or deep beneath the oceans. We'd have some essential supplies like food, medicine, fuel, and water. Maybe even have some gene banks to preserve species. And the last strategy would be to copy the movie Don't Look Up and to ignore the problem until it's too late. We know that it would take collaboration among governments and institutions from many countries to design, build, and launch a series of devices into space in order to prevent the impact. If humanity will be able to pull that cooperation off, that would be a miracle. In any case, NASA takes the threat of asteroids pretty seriously. It has a well-thought-out plan involving early detection, assessment, deflection strategies, collaboration, public communication, and backup plans to protect Earth from these cosmic dangers. So we can only hope that if something like that happens, logic would prevail. Asteroids aren't as rare on our planet as we may think. About 17,000 of them visit us every year. You've probably seen at least one in your life. For example, if you've seen a shooting star. They leave these bright tails behind them as they pass through Earth's atmosphere. Of course, they only look beautiful in the sky. If they reach the ground, the consequences would be catastrophic. Luckily for us, most of them explode 30 to 50 miles above the surface. Their mass is too small for them to withstand such a journey to the end, so most of them remain harmless to us. But we shouldn't underestimate them. Let's start with the smallest ones. 1 to 3 foot high asteroids are about the size of a person. They're too small to cause any real damage. Most often they explode in the atmosphere without even reaching its lower layers. But at the same time, they splash up tons of energy over the surface every time. 13 to 15 foot asteroids, the height of giraffes and mammoths. These larger meteorites come to us less often, once a year and a half. Like the previous ones, they, fortunately, don't pose a serious threat, but they splash out much more energy. 30 feet, the height of a 3 to 4 story building. They visit us once every 10 years, and now we're talking seriously. It throws out a wave that could demolish an entire city. I think you understand how catastrophic the consequences would be if this asteroid touched Earth. 65 feet, multi-story building. They like to visit Earth once every 60 to 70 years. Good news, it explodes at 12 miles above the ground. Its released energy could destroy an entire region if it touched the ground. Bad news, such an asteroid has already visited us recently, and the consequences were pretty rough. It all happened in a city called Chelyabinsk. On February 15, 2013, at about 9:20 a.m. local time, the giant slowed down in the Earth's atmosphere and then broke up into small pieces at 14.5 miles above the Earth. These pieces then flew in different directions. It shattered the windows all over the city and damaged many buildings, including people's houses, schools, and others. It took a while to repair everything, and the scale of this destruction was quite serious. As a result, there were 1,615 injured. But fortunately, no casualties. At least we're safe for the time being. The next such asteroid may come to us only in the 2070s or 80s, and no one knows where exactly it wants to land. Now let's move on. 300 feet. This is the height of the Statue of Liberty together with the pedestal. Such a giant can be seen every 4,500 years, and this is the first asteroid on our list that may literally crash into Earth. The consequences are disastrous. Not only may it demolish an entire city, but it can also set fire to neighboring areas. Well, some people even witnessed such a meteorite land on our planet. The notorious Tunguska meteorite is the biggest asteroid disaster that people have ever seen. It all happened on June 30th, 1908 in eastern Siberia. The meteorite was bright, like a second sun, and people felt the heat wave when it just approached the Earth. It exploded near the river. Fortunately, the whole area was surrounded by taiga, and there were no big cities nearby. But even there, it immediately destroyed a lot of trees. Serious forest fires broke out. The sound of the explosion was heard by people hundreds of miles around. At tens of miles around, all the houses' windows broke. The magnetic storm that resulted from this collision lasted 5 hours. The consequences were truly disastrous, but perhaps this is not the worst thing that awaits humankind. 99942 Apophis, 1,215 feet. It's slightly bigger than the Eiffel Tower. This meteorite, as scientists discovered in 2013, will be our next guest. Collisions of such force occur in about 100,000 years, and this one is gradually approaching. The force of such an explosion is equal to the force of the catastrophic eruption of the Krakatoa volcano in 1883. This eruption is considered one of the most destructive in history. It caused a terrible tsunami. 165 cities and settlements were completely destroyed, and another 132 were seriously damaged. People all around the globe could feel the consequences of this eruption, at least to some degree. Such an asteroid could leave a 3.5-mile crater, and this is one we'll face in the distant future. But calm down, no need to panic yet. By 2070, the meteorite will be almost 174 million miles away from us. It still has a very long journey ahead of it, so we're safe for at least 100 years, or even more. Besides, our planet has survived something even worse. 3,280 feet. This is higher than the tallest tower in the world, the Dubai Burj Khalifa Tower. Such collisions occur once every 500,000 years. We're not sure when such a collision occurred the last time. 70% of our planet is covered with water. If such meteorites fell into the ocean, it would be extremely difficult to find their traces. But we can assume the possible consequences. The wave would have swept across the entire hemisphere. The crater would be about 9 miles in diameter, and that would be a complete disaster. The last event of such a force happened 26 to 28 million years ago. It was an eruption of the supervolcano La Garita, which is located in the southwest of Colorado, USA. It was one of the most powerful known supervolcanic phenomena in history. During this monstrous eruption, a significant part of the current state of Colorado was destroyed. Scientists are still not sure how far the ashes have spread, but there was an even bigger meteorite in the history of mankind. The consequences of that impact were irreversible for an entire species of animals. I think you know what I'm talking about. Chicxulub meteorite, the thing that wiped the dinosaurs off the face of the Earth. This happened about 66 million years ago. These collisions in general happen about every 500 million years. The height of the Chicxulub meteorite was 12.4 miles. It's so high that when it touched the ground, it could reach the stratosphere. Even looking at the 124-mile diameter crater left by this meteorite, you can understand how huge it was. When it collided with the Earth, millions of tons of energy were released. This is an unimaginable disaster. It fell at a very steep angle, creating a giant cloud of dust and chemicals that spread around the world. This dust had a very thin layer, but also a mass of 50 trillion tons. The shockwave swept across the entire planet. It caused several earthquakes. Volcanoes began to erupt actively. Forest fires broke out everywhere, all over the world. The amount of soot and carbon dioxide released into the atmosphere is invaluable. The Earth was closed from the sun for several days. Darkness reigned all over the planet. Planets couldn't produce enough oxygen. so there was nothing to breathe. The temperature on the continents and in the oceans dropped by an average of 50 to 90 degrees Fahrenheit. Sounds horrific, doesn't it? And, of course, it caused one of the greatest extinctions in the history of the Earth's biosphere. Amazingly, the Earth was able to recover after such a catastrophe. This event became the boundary between the Mesozoic and the Cenozoic eras. So now, those who wondered, how could a small meteorite destroy all the dinosaurs, probably understand the answer. Perhaps the largest collision in the history of our entire planet was not a collision with a meteorite, but with an entire planet. This happened many, many billions of years ago. Theia, as this hypothetical dwarf planet was called, crashed into our Earth, releasing an incommensurable amount of energy, just quadrillions of fuel. The Earth then instantly turned into a giant fire, and it was this collision that led to the creation of the Moon. All that sounds terrifying, I know, so let's just hope that you and I will never see anything like this.
Experts have started examining the samples of asteroid Bennu, and they've discovered that the space rock might actually be a fragment of an ancient ocean world. At the moment, scientists are still inspecting bagged and tagged chunks of the 4.5 billion-year-old asteroid. They were collected in space and brought to our planet by NASA's Origins, Spectral Interpretation, Resource Identification, and Security Regolith Explorer mission, also known as OSIRIS-REx. This 7-year-long voyage brought the samples in a return canister that came to a full stop on the 24th of September, 2023. It parachuted into a remote stretch of land in Utah. Scientists at the University of Arizona got roughly 7,000th of an ounce of the asteroid Bennu sample for analysis. There were over 1,000 particles greater than 0.02 inches and 28 particles greater than 0.4 inches. The largest particle was 1.4 inches. It's considered to be an awesome collection, full of relatively large stones. The OSIRIS-REx sample is the biggest carbon-rich asteroid sample that has ever been brought to our planet. It also contains nitrogen, sulfur, and phosphorus. This space rock might help researchers investigate the origins of life on Earth. What makes the asteroid material so unique is the fact that it was captured in space. Most meteorites have to endure a fiery fall through the atmosphere of our planet, and we can only get our hands on their changed bits and pieces. Plus, OSIRIS-REx samples have a phosphate crust never seen in meteorites before. Such high concentrations of phosphate have been previously detected in extraterrestrial ocean worlds. For example, Saturn's moon Enceladus contains phosphates, which is a key building block of life. It makes scientists think that Bennu could be a fragment of an ancient ocean world, too. Even though a lot of work is needed to understand the nature of the carbon compounds found in the asteroid pieces, the whole discovery looks promising. It can offer us insights into how the solar system was formed and how life might have been seeded on Earth. The goal of the OSIRIS-REx mission was to get at least 2 ounces of asteroid material. Experts at NASA were working in new clean rooms constructed especially for this purpose for 10 days in a row, carefully disassembling the sample. Interestingly, when the canister lid was first opened, scientists discovered some bonus asteroid material covering the collector head, canister lid, and its base. There was so much additional material that it slowed down the process of collecting the primary samples. Luckily, NASA's scientists and engineers have been working side by side for years, developing specialized glove boxes and tools that could keep the asteroid material pristine. Within the first 2 weeks, researchers made some quick-look analyses of the initial material. They collected images from a scanning electron microscope, examined infrared measurements, and conducted a chemical elements analysis. X-ray computed tomography was used to produce a 3D computer model of one of the particles. Exactly these early glimpses provided the evidence that the sample contained pretty much carbon and water. Scientists believe that the carbon-rich material, with quite a lot of water-bearing clay minerals, is just the tip of the cosmic iceberg. They hope that each new revelation from Bennu will bring us closer to unraveling the mysteries of our space heritage. For For the next few years, the mission's science team will keep characterizing the samples and conducting analyses needed to make more discoveries. NASA is going to preserve at least 70% of the sample. As part of the OSIRIS-REx program, more than 200 scientists all over the world will explore the properties of the regolith. Almost everything scientists at NASA do is dedicated to figuring out who we are and where we come from. And such missions can also improve our understanding of space wanderers that might threaten Earth.
Asteroids flying around is sometimes like a fierce game of dodgeball, where you never know when some of them can go in your direction. So we can just track the situation and hope for the best. To figure out the risks, scientists from different organizations have to study the positions and paths of the asteroids that come close to our planet, especially those that are at least 0.6 miles wide. And the good news is that none of these asteroids will probably hit us for at least the next 1,000 years. Phew! To give us an idea of their power, scientists did an experiment to simulate the impact of such a gigantic asteroid. The energy released from the collision would be a mind-blowing 100,000 megatons. That's like detonating 15,000 tons of dynamite. Also, if such a big asteroid hit us, Earth would cool down significantly because of all that debris that would go into the atmosphere and block sunlight. Plants wouldn't be able to get their fuel in this case, so we'd all be in trouble, both humans and animals. Thankfully, such mammoth asteroid impacts are quite rare. The larger an asteroid, the longer it takes it to collide with Earth. For example, it's estimated that asteroids with diameters of at least 0.6 miles strike our planet about once every 700,000 years. And if we're talking about even bigger ones that are 3 miles wide, well, those are predicted to come crashing down only once every 30 million years. Yay! But hold on. Don't get too relaxed just yet. Astronomers focus on really large asteroids because those are the ones that can kinda doom our planet if they hit us. Yep, you got it right. In a dinosaur kind of way. Even if one of them didn't erase us completely, the damage would still be enormous. So, there are still some asteroids wandering around that we need to keep an eye on to see how they might evolve over time. Scientists have a model of tracking them where they focus on the parts of an asteroid's path that come close to our planet to see if the space rock poses a risk to us. And it seems there might be one asteroid, 7482, 1994 PC1, 3,600 feet in diameter that might pose some danger. It's supposed to come closer to our planet in the next 1,000 years. And when I say risky, it means there's a 0.0151% chance of it coming within one Earth-Moon distance. It already passed by us in 2022, but we were lucky because it was far enough 1.2 million miles. I'd say we can relax when it comes to asteroid scenarios. For now. Asteroids slamming into Earth would be new for humankind, but not for the planet itself. As I said, there weren't many of those big ones, but they still had enormous consequences. The first one that comes to most people's minds is, of course, the dinosaur asteroid as big as a mountain that struck our home planet around 66 million years ago, near Mexico's Yucatan Peninsula. It was chaotic. Global firestorms and tsunamis were all over the place. Dust was blocking out the sun, and vaporized rock released sulfur, which then led to acid rain and the acidification of the oceans. But there was an even bigger fella that came before that one. Around 2 billion years ago, a gigantic asteroid crashed into our planet and left a massive crater in South Africa. The one we know today as the Redefort crater. And it seems this asteroid might have been even bigger than we all originally thought. Twice as wide as the space rock that erased dinosaurs. The Redefort crater is confirmed to be the biggest visible crater on Earth, with a diameter of about 99 miles. It used to be even bigger when it first formed, though. Maybe even 155 to 174 miles across. It's hard to figure out its true size because the crater has been eroding for the past 2 billion years. Think of it like slicing off layers from the rim of a bowl. The diameter gets smaller with each slice. When the asteroid, 7 to 5 miles wide, that wiped away dinosaurs hit Earth about 66 million years ago, it caused massive destruction. Forest fires, acid rain, tsunamis, and so much ash and dust that it changed Earth's climate. This all made about 75% of life on our planet extinct. The asteroid that created the Redefort crater was not only bigger, but it also traveled at a higher speed, which means the consequences there would have been even worse. But it happened a long time ago, and living beings were different back then. Maybe it was some bacteria that didn't even notice that something unusual was happening. Earth is not the only one. Lots of impacts have happened across our solar system too. For example, in our close neighborhood. Yup, moving to Mercury and its massive crater called the Caloris Basin. It measures about 950 miles across, which is more than the state of Texas. There's a ring of towering mountains around the crater which makes it look even more impressive. You can see different colors in the mosaic image of the Caloris Basin. They tell us more about the geology of the basin. The orange parts represent lava that once flooded the basin. These lava flows covered the original surface and added this specific orange hue. And after the lava flooded the basin on Mercury, smaller craters formed on top of the lava surface. These craters dug into the ground and uncovered the material hidden beneath the lava. Some of this material is blue in color. And this blue stuff could be a clue about what the original floor of the basin had looked like before the lava covered it. Venus, the hottest planet in our solar system, has a thick atmosphere that comes with a pretty good defense system against space rocks. It's so dense that it burns up most meteors before they even reach its surface. As a result, you won't see as many visible craters on Venus as on other rocky planets in our solar system. But Venus still has some scars that can tell us about some serious impacts that happened there. And one of the biggest scars we know about is Meade Crater. It's enormous, about 170 miles in diameter. The inner floor of this crater is relatively flat and kind of brighter than its surroundings. It's possible that the crater ended up filled with a mixture of melted rock after the impact, and maybe even lava from volcanic activity on Venus. Want to get an idea of what Earth might look like without its protective layer called atmosphere? Just take a look at the Moon. Its surface is littered with impact craters. This Tycho is one of the craters you'll easily notice on the Moon. When you look at the full moon, you can spot it as a distinct circle with bright rays that radiate outward, slightly off-center on the lower left side of the moon. This crater, 53 miles wide, has a beautiful central peak in the middle that's topped with an intriguing boulder. The size of this boulder is impressive. It would fill about half of a typical city block here on Earth. When talking about craters, we definitely can't leave out Mars. The red planet has a much thinner atmosphere than Earth. When spacecraft approach Mars, they rely on the planet's atmosphere to slow them down as they enter it. And indeed, the atmosphere helps slow spacecraft down during landing, but it's still not thick enough to completely protect Mars from all those space rocks that are coming all the time. From July to September 2018, a dark spot appeared on the southern pole of Mars. It consists of two distinct patterns. A theory says that the bigger, lighter-colored blast pattern can be the result of an impact shockwave scouring the ice surface. The impact generated winds that spread out and scoured the ice. The inner blast pattern, which is darker in color, occurred because the impacting object managed to penetrate the thin ice layer. As it hit the surface, it sent dark sand and debris flying in all directions.
In 2007, astronomers spotted a massive 54-ton asteroid roaming space relatively close to our planet. But later they lost track of it. That's why the space rock was declared a lost asteroid. Almost 2 decades have passed since then. And in November 2023, a report claimed that the lost asteroid, aka 2007 FT3, might hit Earth in 2024. Such news sounds ominous. But how true is it? Well, NASA disagrees. The U.S. Space Agency has refuted the worrying claims. This statement was issued in response to the announcement that there was a 1 in 11.5 million chance of the asteroid striking our planet on the 5th of October, 2024. The space agency states that at any time in the next century, there are no known asteroids that could pose an impact threat to Earth. NASA and other space agencies are watching the skies nonstop, determined to find, track, and categorize asteroids and NEOs near Earth objects. Hundreds of millions of rocks orbit the sun within the asteroid belt between Mars and Jupiter. But only some of them come relatively close to Earth. NASA classifies asteroids orbiting within 30 million miles of our planet as near-Earth objects. Inside this group, there are particularly worrisome objects. Those are so large and orbit so closely to our home planet that they might turn into a real threat to the world should a direct collision occur. Luckily, the larger an asteroid is, the easier it is for our planetary defense experts to find it. The orbits of the largest space rocks around the sun are normally well known and determined for years and even decades. At the moment, NASA is keeping a close eye on an asteroid named Bennu. It's a fairly large space object reaching 1,610 feet across It might smash into our planet in 159 years. According to experts, the asteroid, which was first spotted in 1999, is quite likely to drift into the orbit of our planet. If it happens, it might collide with Earth by the 24th of September 2182. Asteroid Bennu is thought to be taller than the Empire State Building. If it hits our planet, the collision will release 1,200 megatons of energy. That's an enormous amount of energy that nothing built on Earth could produce. But even though Bennu's chances of colliding with Earth are quite low at the moment, the space rock has still been categorized as a potentially hazardous asteroid. All because it might come as close as 4.65 million miles from Earth. That's the reason why it's also classified as a near-Earth object. Asteroid 99942, 942 Apophis, also known under the dramatic name of the God of Chaos, is another space body we'd better watch out for. It's a near-Earth object about 1,100 feet across. It was discovered in 2004, and at first it was identified as one of the most dangerous asteroids ever detected. Apophis gained notoriety very fast. It was believed to pose a serious threat to Earth. Experts predicted that it would come uncomfortably close to our planet in 2029. Luckily, after a more careful examination of Apophis and its orbit, astronomers concluded that there was no risk of the asteroid colliding with our planet for at least a century. The risk of an impact in 2029 was ruled out completely, as well as the potential impact that could be caused by the asteroid's close approach in 2036. Interestingly, until March 2021, there was still a small chance of a collision in 2068. But then, Apophis made a flyby of Earth, and astronomers took this chance to use powerful radars to estimate the asteroid's orbit around the Sun more precisely. This allowed them to rule out any impact risk for at least the next 100 years.
Hey, look at this rock. At first sight, it looks like a regular boring rock, the likes of which you can see when walking along the beach. Its color doesn't stand out, and its weight is pretty regular, around 4 pounds. But everything changes when you learn that this rock was born on Mars, traveled all the way to Earth, and ended up in Antarctica. Now the story sounds much more fascinating. So let's find out the details. Researcher Roberta Score, who worked on the ANSMET project, which stands for Antarctic Search for Meteorites, of the Denver Antarctic Program, found this meteorite in 1984. If you want to decipher the name of the space traveler, I can help you. It comes from the place where the scientists spotted it, the Allen Hills of Antarctica, hence ALH. And then we've got the year of the discovery and the number of the sample. If you think that Roberta picked up the rock and exclaimed something like, "Woohoo, I'm holding a chunk of Mars," I'll have to disappoint you. At the very beginning, it was totally unclear where the meteorite came from. And one thing confused researchers even more. The meteor was very different from other meteorite groups found on our planet. Okay, but then how did they finally figure out it was a visitor from Mars? All thanks to traces of gas similar to those that make up the atmosphere of the red planet. We learned about its composition thanks to the brave Viking lander that carried out the necessary analysis in situ in 1976. Anyway, back to our rocky discovery. It's actually very special, and not only because the rock arrived from far, far away. Among those several thousand meteorites found on Earth, just around 100 have likely come from Mars. And even so, our guy is different from them and seems to be part of a separate group. So let's go into the past and follow the life story of this cosmic traveler. It most likely formed around 4 billion years ago on its home red planet. One day, which wasn't very different from others, turned out to be life-changing for this peaceful rock. A meteorite impact catapulted into space, and it started its own journey as a small asteroid. At that time, it was way larger than at the moment of discovery on Earth. At one point, ALH got close to Earth and, who knows, probably decided to explore something. That's how, 13,000 years ago, it ended its space journey by colliding with our planet. At the moment, this Martian fragment is the oldest we've got. But at first, it wasn't all that popular. Only in 1996 did it become way more famous after a groundbreaking discovery. You see, some NASA researchers started wondering, well, the fragment is obviously very old, but then Could it have recorded any traces of life that could have been thriving on Mars at the time ALH formed on the red planet? And guess what? Those scientists turned out to be right. They detected traces of very fine magnetite particles. Those were completely similar in structure and chemical composition to the particles we have on Earth. They're called magnetofossils, and magnetotactic bacteria produce them. So it might mean that, at one point, there were some forms of life on Mars. In April 2020, scientists from the Japanese Space Agency made another discovery. They detected nitrogen containing organic material of Martian origin in our meteorite. So, who knows what new astounding secrets further examination of the meteorite might reveal? At the moment, though, all you can do is travel to Antarctica and find more of them. The thing is, this place is great for meteorite hunting. Surprisingly, we have found nearly 50,000 meteorites in Antarctica, and hundreds of thousands are still waiting to be discovered. Each of these space rocks can tell us a story of the evolution of the solar system. For example, the very first lunar rock found on the icy deserted continent proved that chunks of space objects larger than asteroids can also end up on Earth. So, let's say you got inspired and decided to go meteorite hunting all the way to Antarctica. Well, get ready for some serious challenges. Despite their potential abundance, finding space rocks isn't as easy as it might seem. You'll have to visit remote areas, and there's still no guarantee that you'll be able to spot a meteorite. And that's actually a huge problem. Meteorites are vanishing from sight. Currently, scientists find about 1,000 meteorites in Antarctica each year. But according to a new study, about 5,000 more get hidden out of sight every year. The culprit is warming temperatures. Worried scientists created a model that could help them figure out where those meteorites might surface. This model was quite complicated, taking into consideration snow cover, surface temperature, the speed at which ice flows, and even the steepness of the terrain. After that, they ran simulations under various warming scenarios. It turned out that meteorites indeed sank out of sight as temperatures rose. To say that the researchers were upset is obvious. They didn't expect that climate change would affect their work so much. Even though those areas are below freezing, people still managed to ruin a crucial archive of the solar system. But let's get back to your meteorite hunt. If you want your chances to find one to be higher, travel to the base of mountains or outcrops where ice, which usually flows to the lower ground, is forced to move upward. But make sure to take your windbreaker with you. In those places, powerful winds brush away snow, exposing bright, vivid blue ice. Instead of melting, this ancient ice can change directly into water vapor, and it helps expose meteorites that would otherwise remain hidden. You need to hurry though. Meteorites at the surface disappear quickly. Even when temperatures are well below freezing, the rocks can still absorb some of the sun's heat and melt the ice. It's like they're creating underground, or shall I say under ice, tunnels for themselves, sinking and hiding from sight. Sometime later, refreezing closes the entrance to those tunnels, effectively trapping meteorites inside, tucked out of sight. Now, scientists admit it's very tricky to find working methods to spot meteorites. And if we don't hurry and develop such methods, we might lose between 80,000 and 250,000 space rocks in total. No wonder scientists are on a mission to find more meteorites. They're focusing on meteorite stranding zones. Those are places where meteorites often gather on the surface because of specific features of geology, ice flow, and climate conditions. As you already know, you can find meteorites on blue ice without snow cover. This makes meteorites easy to spot. But finding such hotspots is often pure luck. Or you gotta sit day and night, scouring maps and satellite images in attempts to spot blue ice zones near research stations. Let me introduce Veronika Tolinov, a glaciologist, and her team. They've taken things to the next level by developing a smart Antarctic-wide map. To do it, they've used machine learning and satellite data from NASA, the Canadian Space Agency, and others. This map highlights areas where meteorites might be hiding based on past finds and all kinds of climate and ice data. Apparently, the best places to find meteorites are along the edges of the continent and near mountains with blue ice. Unfortunately, it's not just the blue ice that matters. The temperature and speed of the ice flow are also super important. For example, if the ice flows too quickly, meteorites get swept away before they can accumulate. So, if you want to find a meteorite, you have to wait for very precise conditions. The surface temperature has to stay below 16 degrees Fahrenheit almost all the time. Otherwise, meteorites sink. You can start with the Allen Hills region. Yup, that's where our ALH friend was discovered. This area is kind of a meteorite gold mine with more than 1,000 finds. But there are even more promising places, like the Fimbulheimen Mountains, and no one has searched there yet. You might be the first. In any case, with this new map, researchers developed a where-to-go index that ranks the best meteorite hunting spots, making future field trips much more targeted. And with plenty of blue ice regions still unexplored, there are tons of meteorites just waiting to be found. So, what are you waiting for?
The South Pole is more than penguins and endless snow. There's a hidden ghost world within it. Look, it's right here on the globe. Don't confuse Antarctica with the Arctic, which is at the top of our maps. Much smaller in size, and, let's face it, way less mysterious. The ice sheet covering Antarctica is about 1 to 3 miles thick, which is up to 16 Eiffel Towers stacked on each other. This massive blanket hides the true features and contours of Antarctica's land. We still don't know much about this mysterious continent, and it is ice and snow that are to blame. We still don't even know the true shape and size of this continent. Mapping Antarctica without some huge shovels is an incredibly hard task. But satellites learned to penetrate the ice with their cameras. And now we know there's actually an enormous, dramatic ancient landscape beneath the snow. The ghost of the past. About 90 million years ago, Antarctica was a much warmer place. It was actually a lush rainforest with tons of plants and probably teeming with life. It even had rivers flowing through it. Then the ice came. This happened about 34 million years ago, during the transition from the Eocene to the Oligocene, when our planet cooled significantly. It was the beginning of one of our several ice ages. The land remained, but now was hidden under ice and snow that got thicker and thicker. To a regular eye, Antarctica turned into a white desert, vast, flat, and featureless. Time went on. This massive ice sheet moved around, smoothing and shifting the ground beneath it. Over the millions of years, it changed what the land looked like. Now, if we looked under the ice, it wouldn't hold any signs of the original South Pole, except for one place. In areas where the ice is especially thick and doesn't move much, like in East Antarctica, it has actually worked the other way around. It became like a super thick blanket that protects the land. Normally, things like wind or rain slowly wear away the ground over time, changing its shape. But since we have this protective ice blanket, it prevents these natural processes from reaching the stuff underneath. So, the ground stayed almost the same for millions of years, like it's been frozen in time. This special area near the Aurora and Schmidt subglacial basins has become the ghost of Antarctica's landscape. This place was barely touched even since it was first covered in snow 34 million years ago. This is a historical footprint, a place that can tell us what Antarctica's ground looked like before it became a freezing nightmare. As scientists peered under East Antarctica, they saw an amazing ghost. The traces of the rivers that were flowing there millions of years ago, various valleys, and some weird little islands, as well as 3 big chunks of land shaped like the letter U. Hey, what's that all about? You see, the continents on our planet are moving constantly, sliding along the red-hot lava mantle like cereal on milk. Over history, they came together and broke apart several times. Hundreds of millions of years ago, several continents were a part of one enormous Gondwana. Antarctica was one of them. It used to be one huge landmass. But when Gondwana broke apart, the poor continent got stretched by tectonic forces. Parts of land were pulled away from each other. Whoosh! And they got torn apart. And that's how we got these big chunks or blocks of land under thick layers of ice. In any case, scientists now want to explore this ghost a bit more. But to study it deeply, they need to actually drill down through the ice, like using a straw to get to the bottom of a thick shake. This will help them pick up some rocks and dirt from way below to learn more about the Earth's history and climate. Antarctica is the 5th largest continent in the world, approximately bigger than the entirety of Europe or Australia, competing with the entire South America in size. Aside from East Antarctica, we discussed there are several more regions: Antarctica Peninsula, South Pole, West Antarctica, and the Ross Sea. The continent is basically a frozen sandbox, and all its hidden, mysterious landscape is actually less explored than Mars's terrain. We only know for sure that without ice, it wouldn't just be flat and empty, but an entire world full of big mountains, huge canyons, and even fiery volcanoes. Some of these volcanoes are so huge that they peak above the layers of snow. In West Antarctica alone, there are at least 138 volcanoes, though only about 8 or 9 are active today. One of the craziest ones is Mount Erebus, the southernmost volcano and the tallest one on the continent, about 12,500 feet high. And deep beneath the ice sheet, this guy hosts incredible, beautiful subvolcanic caves. The temperatures there are warm enough for t-shirts. The Antarctic Peninsula, or Lesser Antarctica, looks like a bunch of mountainous islands deeply underground. It has newer volcanic rocks that are part of the Pacific Ring of Fire, which is like a giant circle of volcanoes and earthquake zones around the Pacific Ocean. The Greater Antarctica is a huge part, almost as big as Australia. It consists of East Antarctica and the South Pole. Beneath the ice, it's a place of rocks that have been around for a very, very long time, including the special zone we mentioned. You probably know that Antarctica is nearly devoid of humans. No wonder, with a mean temperature of about minus 46 degrees Fahrenheit. But even though this place is horrifyingly cold and deserted, life still clings on. You guessed it, in the underworld. In 2017, scientists found DNA traces of algae, moss, and even possibly unknown small animals in the deep caves. That means that even in such crazy conditions, there are still unique ecosystems thriving in little isolated warm pockets beneath the snow. There was another incredible find beneath Antarctica's Ross Ice Shelf, a lively ecosystem vibing within an underground river. Scientists have long suspected that Antarctica's underworld should have some freshwater lakes and rivers. One day, a satellite spotted a groove there. They decided to explore it and used a hot water drill to melt their way through the ice. As they reached the underworld, they dropped a camera into one of those hidden fresh rivers. And at first, they thought they'd find just some rocks or something. But instead, they stumbled upon hundreds of amphipods, tiny shrimp-like creatures. Little ones instantly swarmed around the lens. Shrimps blocked the camera and scientists couldn't check out what they wanted to. Pretty funny, but at least that means that there really is an important ecosystem deep within Antarctica. Now, they're gonna explore it. And all this is just the beginning of the mysterious underworld. Antarctica's snow also hides the deepest canyon on Earth under the Denman Glacier. Well, Mariana Trench is still the deepest point on Earth, but it's a part of the oceanic crust, geologically speaking. Also, in 1958, explorers found a huge mountain range under the ice, as big and tall as the famous Alps Mountains. The range stretched for about 745 miles with peaks as high as 1.7 miles. And all this magnificence is buried under tons of ice. Who knows what else we might find there? Antarctica holds about 60% of our entire planet's freshwater, which means it would be pretty bad if it melted. For example, there's this Doomsday Glacier, officially known as Thwaites Glacier. It's a huge ice formation, about the size of Florida, and it's melting right now. Every year, the sea levels rise by 4% because of it. If this guy melts away completely, the sea levels all around the world will increase by 2 feet, which might not sound like a lot, but it would be catastrophic for coastal areas. Luckily, researchers have found that even if its ice shelf were to collapse in the next 50 years, the glacier itself wouldn't retreat as quickly as they fear.